You did it this morning. You'll do it again before you go to bed tonight. You've probably done it dozens of times already today without giving it a second thought. Whether you're wondering about tomorrow's weather, searching for the perfect recipe, settling a heated dinner table debate, or diving deep into research for work or personal curiosity, you perform this simple action. You open a web browser or grab your phone, navigate to that familiar search box, type in a few words that capture your question or need, and press enter. In less than half a second, something extraordinary happens. The entire sum of human knowledge seems to materialize at your fingertips, perfectly organized and ranked by relevance to your specific question. What feels like magic is actually science. What seems simple is breathtakingly complex. What appears instant requires one of the most sophisticated technological orchestrations ever achieved by human ingenuity. That simple search you just performed triggers one of the most complex technological symphonies ever orchestrated by human ingenuity, a process more intricate than launching a rocket to the moon. Your query sets in motion a global network more coordinated than a 1,000-piece orchestra, involving more individual components than exist in most countries' entire technological infrastructure. Behind that innocent search box lies a technological ecosystem so vast and sophisticated that it processes more information every day than entire civilizations created throughout most of human existence. Armies of invisible digital explorers, more numerous than all the researchers who ever lived, spring into action the moment you press enter, racing across the internet at the speed of light. Artificial intelligences, more sophisticated than science fiction writers dared imagine, analyze your words, decode your intentions, and predict your needs with startling accuracy and unprecedented speed. Massive data centers, consuming more electricity than small countries, coordinate their computational resources to serve your curiosity in milliseconds rather than hours or days. All of this happens so you can find out whether that actor was in that movie, discover how to fix your leaky faucet, or explore the mysteries of quantum physics. The technology that makes this possible represents one of humanity's greatest collaborative achievements, a system that democratizes access to information on a scale never before imagined in human history. Every time you search, you're having a conversation with the accumulated wisdom of our entire species, accessing knowledge that previous generations could never have dreamed of reaching so effortlessly. This is the story of what really happens when you Google something, a journey through the invisible digital universe that makes the impossible seem routine and transforms curiosity into instant understanding. Chapter 1: The First Spark, User Query Input and Digital Orchestration. The moment your fingers touch the keyboard to begin typing your search query, you've become the conductor of an invisible orchestra that spans the globe. Every keystroke you make triggers a cascade of technological responses that most people never imagine, let alone understand fully. Before you've even finished typing your complete question, Google systems are already at work, analyzing patterns and making intelligent predictions about what you might be asking. Predictive algorithms are analyzing your keystrokes in real time, anticipating what you might be asking before you finish formulating the complete thought in your own mind. The autocomplete suggestions that appear aren't random guesses. They're the result of sophisticated analysis of billions of previous searches, language patterns, and contextual understanding. These predictions draw from an enormous database of human curiosity, representing every question that millions of people have asked before you. The system understands not just what you're typing, but the context of your search, your location, your previous search history, and even the time of day. This intelligent prediction system saves countless hours of human time while simultaneously providing Google with valuable insights into what information people are actually seeking. When you finally press enter, you're submitting more than just a few words. You're providing a complex set of signals that sophisticated algorithms will decode and interpret. Google's natural language processing engines don't just read your query, They decode it with the sophistication of a literature professor analyzing poetry for deeper meaning and context. The system understands synonyms, colloquialisms, common misspellings, and even the implied context that you didn't explicitly include in your search terms but probably meant. Your search query becomes the catalyst for an intricate dance of technology that spans the globe, involving millions of servers and billions of data points. But before any of this global technological coordination can begin, your query must undergo a process that's like a digital spa treatment. Specialized cleaning algorithms work like meticulous editors, removing unnecessary words, correcting obvious typos, standardizing formatting, and preparing your query for optimal processing. Common words like the, and, or, and of are often filtered out because they don't add meaningful search value, though context determines their importance. The system also normalizes your query, converting it to a standard format that the search algorithms can process most effectively and efficiently. This pre-processing phase happens so quickly that you never notice it, but it's crucial for ensuring that your search returns the most relevant and useful results. Meanwhile, Google systems are performing what amounts to digital mind reading, analyzing not just what you've written, but what you actually meant to ask. The query processing algorithms consider your search history, your geographic location, your device type, your language settings, and dozens of other contextual factors. This contextual analysis helps Google understand that when you search for football, you probably mean American football if you're in the United States, but soccer if you're in Europe. The semantic understanding allows Google to comprehend that automobile repair and fix my car are expressing the same fundamental need, even though they use completely different words. Google's systems are simultaneously building what's essentially a digital personality profile based on your search history, helping personalize future results to better serve your specific interests and needs. This personalization happens while maintaining your privacy through sophisticated techniques that learn about general preferences without storing detailed personal information about your individual identity. The query processing system also performs linguistic archaeology, digging deep into the structure and hidden meanings of human language to understand what you're really asking. Advanced natural language models can understand context, implied relationships, cultural references, and even emotional undertones in your search queries. All of this sophisticated analysis happens in the background while your processed query is being routed through Google's global network infrastructure. Your query gets sent to what's essentially a digital mission control center, where sophisticated scheduling and routing algorithms determine exactly how and where your search will be executed. The system decides which data centers will handle your request, which servers have the most relevant information, and how to optimize the entire process for speed and accuracy. Load balancing algorithms distribute computational work across thousands of servers to ensure that no single machine becomes overwhelmed while others remain idle. The routing system considers network latency, server availability, current computational loads, and even predictive models about future traffic patterns. Your seemingly simple search query has now been transformed into a complex computational task that will engage thousands of individual computers working in perfect coordination. The optimization algorithms ensure that your search will be processed by the servers that can deliver results fastest and most efficiently. Geographic factors play a crucial role, with systems attempting to process your search using resources that are physically closer to your location when possible. The entire query pre-processing and routing phase typically completes in just a few milliseconds, setting the stage for the massive information retrieval process that comes next. Your processed and optimized query is now ready to begin its journey through Google's vast index of human knowledge. But even before your query reaches the search algorithms proper, it undergoes further refinement through Google's advanced understanding systems. BERT, MUM, and other sophisticated language models analyze your query to understand not just the words you've used, but the deeper meaning and intent behind those words. These AI systems can understand that when you search for apple, you might be looking for fruit information, technology products, or even stock market data, depending on additional context clues. The intent classification system categorizes your search into dozens of different types: informational, navigational, transactional, local, image-based, news-related, or any combination of these categories. This classification is crucial because different types of searches require different approaches to deliver the most satisfying results. A search for pizza delivery requires immediate, local, actionable information, while history of pizza calls for comprehensive, educational content. The system's understanding of search intent has evolved dramatically from simple keyword matching to sophisticated comprehension of human information needs. Modern query processing includes entity recognition that identifies specific people, places, organizations, products, or concepts mentioned in your search. When you search for Tom Hanks movies, the system recognizes Tom Hanks as a specific person, understands that you're looking for his filmography, and can provide structured information about his career. This entity recognition extends to understanding relationships between entities, temporal information, and contextual connections that help provide more comprehensive and relevant results. The query expansion process automatically includes related terms and concepts that might help surface more relevant results, even when you haven't explicitly included those terms. A search for smartphone battery life might automatically consider related concepts like mobile phone power consumption, battery optimization, and charging habits. This expansion happens intelligently, adding conceptually related terms without diluting the focus of your original query. The system also performs query refinement based on collective user behavior, understanding how other users with similar information needs have successfully found what they were looking for. If millions of users who search for iPhone battery consistently click on battery replacement services, the system learns to emphasize that type of content for similar queries. This collective intelligence creates a continuous feedback loop where successful search patterns improve future results for everyone. The spelling correction algorithms have evolved far beyond simple dictionary checks to include contextual understanding and phonetic similarity. The system can correct not just obvious typos, but also handle complex errors like swapped words, phonetic spellings, and context-dependent corrections. New York is obviously what you meant when you typed New Rock, but the system can also understand that Morning Star might be what you intended when you search for Morning Star. These corrections happen invisibly and instantly, ensuring that minor typing errors don't prevent you from finding the information you need. The query processing also includes sophisticated temporal analysis that understands when your search might be time-sensitive or relate to current events. A search for election results during an election period is understood to require current real-time information, while the same search months later might be satisfied with historical data. This temporal intelligence ensures that search results remain relevant and useful, regardless of when you perform your search. The system maintains awareness of trending topics, breaking news, seasonal patterns, and cyclical information needs that influence what results will be most valuable. Cultural and linguistic analysis ensures that search results are appropriate for your cultural context and language preferences. Idioms, cultural references, and region-specific terminology are understood and handled appropriately, ensuring that search results make sense within your cultural framework. The system understands that biscuits means something different in American versus British English and adjusts results accordingly. This cultural intelligence extends to understanding holiday patterns, local customs, regional preferences, and cultural sensitivities that influence what information will be most appropriate and useful. Privacy protection is built into every step of the query processing pipeline, with sophisticated systems that provide personalized results while protecting your individual privacy. Advanced techniques like differential privacy allow Google to learn from aggregate user behavior without storing or analyzing individual search histories in ways that could compromise privacy. The system can understand general patterns and preferences while maintaining strict boundaries around personal information. This privacy-preserving personalization represents one of the most sophisticated balancing acts in modern technology, providing customized experiences while respecting user privacy rights. Machine learning models continuously improve the query processing system by analyzing billions of searches and their outcomes to identify patterns and opportunities for enhancement. These models can detect when certain types of queries consistently produce unsatisfying results and automatically adjust the processing algorithms to better serve those information needs. The learning process operates at massive scale, processing more linguistic data than any human could analyze in multiple lifetimes. This continuous improvement means that query processing becomes more sophisticated and accurate over time, adapting to changing language patterns and evolving user expectations. Quality assurance systems monitor every aspect of query processing to ensure that the systems are working correctly and producing high-quality results. Automated testing continuously validates that query understanding, intent classification, entity recognition, and other processing components are functioning as expected. Human quality raters regularly evaluate search results to identify areas where the query processing algorithms might need refinement or adjustment. This combination of automated monitoring and human evaluation ensures that the query processing system maintains high standards of accuracy and usefulness. Real-time monitoring systems track query processing performance across all of Google's global infrastructure, ensuring that the system can handle traffic spikes and maintain consistent response times. During major news events or trending topics that generate massive search volume, the system automatically scales processing capacity to handle the increased load. This scalability ensures that your search experience remains fast and reliable, regardless of global search patterns or current events that might be driving unusual traffic volumes. The monitoring extends to detecting and responding to malicious queries or attempts to manipulate search results through artificial query generation or other deceptive practices. International and multilingual query processing presents unique challenges that Google's systems handle through sophisticated language detection and cross-linguistic understanding. The system can automatically detect what language you're searching in and provide appropriate results, even when you're searching in a language different from your usual preference. Translation and cross-linguistic search capabilities allow the system to find relevant content in multiple languages when appropriate, expanding the range of information available to answer your query. This multilingual capability is particularly valuable for users who speak multiple languages or are searching for information that might be better covered in languages other than their primary language. Finally, your fully processed, analyzed, understood, and optimized query is ready to be matched against Google's vast index of web content. The pre-processing phase has transformed your simple text input into a rich, multi-dimensional understanding of your information need. This understanding includes not just the literal words you typed, but your likely intent, your cultural and linguistic context, your personal preferences, temporal factors, and sophisticated semantic expansion. The query processing system has prepared your search for optimal matching against billions of web pages, with every aspect of the analysis designed to help you find exactly the information you need. Your query now carries with it a comprehensive understanding of who you are as a searcher, what you're trying to accomplish, and what type of results will best serve your information needs. This remarkable transformation, from simple keystrokes to sophisticated search understanding, represents one of the most impressive achievements in artificial intelligence and natural language processing. The journey from your typed words to actionable search intelligence happens in milliseconds, but involves some of the most advanced computational linguistics and machine learning systems ever created. Your enhanced query is now ready to enter the next phase of the search process, where it will be matched against the vast index of human knowledge. Chapter 2: The Great Discovery, Web Crawling and the Digital Expedition. Long before you even thought of your question, Google's army of web crawlers was already preparing for your search, methodically cataloging the entire internet. Meet Googlebot, not a single robot, but a distributed system of web crawlers that never sleep, never rest, and never stop exploring. These digital explorers operate 24 hours a day, 365 days a year, following links from web page to web page, like tireless researchers in the world's largest library. They're not random in their exploration. Each crawler operates with sophisticated intelligence about where to go next, what to prioritize, and how to be respectful. Imagine millions of tiny digital Lewis and Clark expeditions, constantly traveling through the vast landscape of the internet, mapping every corner, every link, every piece of content. Googlebot doesn't just visit websites once and forget them like a tourist, checking items off a bucket list. Popular sites might be crawled multiple times per day, while less active sites might be visited weekly or monthly. The system maintains a complex schedule that would make the most organized personal assistant jealous, balancing fresh information with respect for website server resources. High-traffic news sites get constant attention because their content changes rapidly, while a personal blog about vintage stamps might only need checking once a month. The crawlers understand website patterns, learning when sites typically publish new content and adjusting their visit schedules accordingly. This isn't just efficient resource management, it's digital courtesy, ensuring that Google's data gathering doesn't overwhelm the very websites it's trying to help people find. The scheduling system even adapts to time zones, understanding that a Japanese news site might publish most actively during Tokyo business hours. But how does Googlebot know where to go in the vast expanse of the internet? The discovery process is like a combination of treasure hunting and social networking. Multiple sophisticated methods work together to map the ever-expanding web. First, there are the links, billions of them, connecting web pages like a vast neural network. When Googlebot finds a new link on an existing page, it adds that destination to its ever-growing list of places to explore. It's like having a friend recommend a restaurant, and then that restaurant recommending 3 more places you should try. Each web page becomes a curator, pointing Googlebot toward other valuable content through its outbound links. This link-following process creates a continuous chain of discovery, where one web page leads to another, which leads to another, in an endless expedition. The quality and context of these links matter enormously, with links from authoritative sources carrying more weight in the discovery priority queue. Website owners also actively participate in this discovery process by submitting XML sitemaps, which are essentially treasure maps that tell Google exactly where to find content. Through Google Search Console, webmasters can directly submit new URLs, request recrawling of updated content, and provide hints about their site structure and importance. It's like putting up a sign that says, "New content here," and Google's crawlers are always looking for these signals. Sitemaps contain not just lists of URLs, but metadata about when content was last modified, how often it changes, and what priority the website owner assigns. This collaborative approach between website owners and search engines creates a more efficient and comprehensive crawling process, ensuring valuable content doesn't get overlooked. Large websites might submit multiple sitemaps, organizing them by content type, language, or update frequency to help crawlers navigate their complex structures more effectively. Social media has become another major discovery channel in the modern web ecosystem, acting like a global recommendation engine powered by human behavior. When content gets shared on Twitter, Facebook, LinkedIn, or any other social platform, Google's systems often detect these signals and add linked content to their crawling queue. It's like having millions of human curators constantly recommending new content to explore. These social signals don't just help with discovery, they also provide valuable context about content popularity and relevance. A research paper that gets shared thousands of times on academic Twitter might get prioritized differently than a blog post that receives no social attention. This social layer of discovery helps Google understand not just what content exists, but what content real people find valuable enough to share. The viral nature of social media means that truly exceptional content can be discovered and crawled within hours of publication, ensuring trending topics become searchable quickly. Managing billions of web pages requires exquisite orchestration that would make a master choreographer weep with envy. Google's crawl scheduling system operates like mission control at NASA, determining not just what to crawl, but when, how often, and with what priority. This system considers numerous factors that create a complex decision matrix for each potential crawl: website importance, update frequency, server capacity, and content changes. The scheduling algorithms balance these factors dynamically, creating crawl schedules that maximize information gathering while respecting technical limitations and preferences of website owners. The system also considers global events, automatically adjusting crawling patterns during major news events when certain types of content become more critical to discover quickly. The system also respects the digital equivalent of "Do Not Disturb" signs through robots.txt files, demonstrating the collaborative and respectful nature of web crawling. Before crawling any site, Googlebot checks this simple text document that serves as a communication channel between website owners and search engines. If a website owner says, "Please don't crawl my private member area," or "avoid my administrative pages," Googlebot respects those requests. This respect for robots.txt demonstrates the collaborative nature of web crawling, where search engines and website owners work together. It's a digital social contract that has helped maintain the open nature of the web while respecting the rights and preferences of content creators. Website owners can be incredibly specific in their robots.txt instructions, directing crawlers to avoid certain file types, limiting crawling speed, or specifying different rules. When Googlebot visits a web page, it's performing digital archaeology with the precision of a master detective and the thoroughness of a forensic investigator. The system doesn't just grab the visible text like a speed reader, it analyzes the entire page structure with microscopic attention to detail. It understands HTML markup, identifying headers, paragraphs, links, images, and multimedia content with their proper contextual relationships. It follows the page's link structure to understand the site's hierarchy and the relative importance of different sections. The crawler examines metadata, alt text for images, structured data markup, and even the page's loading speed and mobile friendliness. Every element is catalogued and analyzed for its potential contribution to understanding what the page is about and how useful it might be to searchers. The system can even detect the emotional tone of content, understanding whether an article is positive, negative, or neutral in its presentation of information. Modern crawling has evolved dramatically to handle the complexity of today's web, which is far more sophisticated than the static HTML pages of the internet's early days. Googlebot can now render pages in a browser-like environment, executing JavaScript to see the page as a human visitor would, waiting patiently for dynamic content to load. This capability is crucial because many modern websites use JavaScript, AJAX, and dynamic content loading to create interactive user experiences. A single page might load basic HTML first, then use JavaScript to fetch and display the actual content, images, and interactive elements. Google's crawlers must wait for all this dynamic loading to complete, just like a human visitor would, to truly understand what the page offers. This rendering capability ensures that modern, interactive websites are properly understood and indexed. The system can even handle complex single-page applications that dynamically change their content based on user interactions. Understanding the full range of content. The crawling process also involves sophisticated duplicate detection and content quality assessment that rivals the most advanced plagiarism detection systems. As Googlebot explores the web, it encounters millions of pages with similar or identical content, whether through legitimate syndication, templates, or deliberate copying. The system must identify these duplicates and determine which version is the original or most authoritative. This involves analyzing publication dates, domain authority, content depth, and numerous other signals to make intelligent decisions about which version deserves to be indexed. It's like having a librarian who can instantly recognize when the same book appears in multiple editions and decide which version belongs on the main shelf. The duplicate detection goes beyond simple text matching, understanding when content has been translated, summarized, or republished, with minor modifications. Googlebot also functions as a quality control inspector, constantly evaluating whether pages meet Google's evolving standards for inclusion in the search index. The system looks for signs of spam, automatically generated content, malicious software, and other quality issues that could harm user experience. Pages that try to manipulate search rankings through keyword stuffing, hidden text, or other deceptive practices are identified and filtered out with machine learning precision. This quality assessment happens in real time during crawling, with sophisticated algorithms trained to recognize the difference between helpful content and manipulative spam. The goal is ensuring that only valuable, trustworthy content makes it into the search index where it can be discovered by users. The quality assessment extends to technical factors as well, evaluating page load speeds, mobile compatibility, and overall user experience metrics. The scale of modern web crawling defies comprehension, operating at a magnitude that challenges our understanding of information processing. Google's crawlers process billions of pages regularly, handling everything from massive e-commerce sites with millions of product pages to personal blogs with handful of posts. The system must scale dynamically to handle sites of vastly different sizes and complexities, from a simple restaurant website to a news organization publishing hundreds of articles daily. Each site requires different crawling strategies. News sites need frequent, rapid crawling, while reference sites might need deep, comprehensive crawling to understand their full content structure. The crawling infrastructure automatically adapts its approach based on site characteristics, ensuring efficient coverage across the entire spectrum of web content. The system processes more pages in a single day than a human could read in multiple lifetimes, all while maintaining quality standards and respecting technical limitations. The technical infrastructure supporting this massive crawling operation represents one of the most sophisticated distributed computing systems ever created. Thousands of servers across multiple continents coordinate their crawling activities, sharing information about what's been discovered and what needs attention. The system handles network failures gracefully, automatically redistributing work when servers go offline or internet connections experience problems. Load balancing ensures that no single part of the infrastructure becomes overwhelmed, while geographic distribution means websites can be crawled from nearby locations. This global approach also helps with cultural and linguistic understanding, as crawlers in different regions can better understand local content patterns and language nuances. Finally, the crawling system operates within a framework of global internet infrastructure, respecting network limitations, geographical boundaries, and cultural considerations. Crawlers operating from different geographic locations might see different versions of websites due to content delivery networks, regional restrictions, or localized content. The system must understand these variations and crawl appropriately, for different global audiences. It also must navigate the technical challenges of internet infrastructure, from temporary server outages to network congestion. This global perspective ensures that search results can serve users worldwide with content that's not just relevant, but also accessible and appropriate. The result is a constantly updated, comprehensive map of human knowledge that serves as the foundation for every search you'll ever perform. Chapter 3: The Great Library, Indexing and the Palace of Digital Knowledge. Imagine the Library of Alexandria, but instead of scrolls and papyrus containing the knowledge of the ancient world, picture a digital repository. This digital repository contains every piece of information ever published on the internet, perfectly organized and instantly searchable. This is Google's indexing system, a technological marvel that transforms the raw content discovered by Googlebot's endless expeditions into the world's most sophisticated information retrieval system. What happens after those digital explorers return from their journeys across the web is nothing short of miraculous. Armies of digital librarians, more numerous and precise than any human workforce ever assembled, spring into action with the speed of supercomputers and thoroughness of master scholars. They don't just catalogue information, they understand it, organize it, and prepare it for the moment when your curious question will need an answer. This indexing process represents one of humanity's greatest achievements in information science, turning the chaotic vastness of the internet into an organized, searchable universe of knowledge. The moment fresh content arrives from Googlebot's crawling expeditions, sophisticated processing systems begin their meticulous work, like teams of expert librarians analyzing every new acquisition. But these aren't ordinary librarians. They're artificial intelligences with capabilities that would seem magical to previous generations. They extract not just the obvious text that humans can see, but understand the deeper context, meaning, and relationships within every piece of content. The system identifies the main topics and subtopics of each page, using advanced natural language processing that can read between the lines, understanding implied meanings. It recognizes named entities, those important people, places, organizations, dates, and events that give content its factual foundation, and understands how they relate to each other. Images are analyzed not just for their technical properties like file size and format, but for their actual visual content using computer vision systems. These computer vision systems can identify objects, scenes, emotions, and activities with remarkable accuracy. At the heart of Google's search capability lies one of the most elegant and powerful data structures in computer science, the inverted index. This system is so ingenious that it reverses our normal way of thinking about information storage. Instead of organizing information like a traditional library where you look up a book to find the words inside it, the inverted index works backwards. The inverted index allows you to look up any word and instantly find every document that contains it. Think of it as the ultimate cross-reference system, where each significant word in the English language and hundreds of other languages has its own filing cabinet. Each filing cabinet contains references to every web page where that word appears. But this isn't just a simple word counting exercise. It's a sophisticated understanding of language, context, and meaning. For every word in every document, the index maintains crucial metadata, exactly where in the document the word appears, whether it's in a headline or main text. The index also tracks how many times the word occurs, what other words surround it, and what role it plays in the overall meaning of the content. This reverse lookup system is what allows Google to perform what seems like magic, finding relevant pages in milliseconds rather than hours or days. When you search for chocolate chip cookies, the system doesn't need to read through billions of web pages looking for those words. Instead, it instantly consults the filing cabinets for chocolate, chip, and cookies, finds all the documents that contain these terms, and uses sophisticated algorithms. These algorithms determine which pages are most relevant to your specific combination of words. The inverted index contains far more than simple word lists. It's a multi-dimensional map of human knowledge that understands synonyms, related concepts, and emotional context. The system knows that delicious and tasty might be relevant to cookie searches, even if your query doesn't contain those exact words. It can identify when cookies refers to baked goods versus computer cookies versus browser settings based on surrounding context clues. Modern websites don't just communicate in the visible language that humans read, they also speak in hidden structured data markup. This structured data provides machines with precise information about what content really represents. Google's processing systems are fluent in multiple machine languages, including schema.org, JSON-LD, microdata, and dozens of other structured data formats. Websites use these formats to provide additional context about their content. When a restaurant website marks up its menu with structured data, Google doesn't just see text about margarita pizza, $12.99. It understands this as a specific menu item with a name, price, and category, along with potential additional information like ingredients, nutritional data, or customer ratings. This structured understanding allows Google to create rich search features that go far beyond simple text results. When you search for Italian restaurants near me, the system can provide not just links to restaurant websites, but actual menu items, prices, hours. It can also provide customer reviews and reservation availability, all because it understands the structured data that websites provide about their offerings. This structured data processing extends to virtually every type of content on the web, creating a semantic understanding of information that approaches human-level comprehension. Event listings become searchable by date, location, ticket prices, and performer information. Product pages become rich with price comparisons, availability data, technical specifications, and customer feedback. News articles are understood not just as text, but as stories with specific topics, publication dates, author credentials, and factual claims. Recipe pages become structured collections of ingredients, cooking times, difficulty levels, and nutritional information that can be searched and compared across millions of different cooking websites. This semantic understanding transforms the web from a collection of text documents into a structured database of human knowledge. Information can be found, compared, and combined in sophisticated ways. Quality control in Google's indexing process operates like the most rigorous academic peer review system ever created, but at a scale and speed that defies human capability. Not all content is created equal, and Google's systems include sophisticated mechanisms to evaluate content quality, originality, and trustworthiness. These digital gatekeepers use machine learning models trained on millions of examples of high and low quality content to identify duplicate material, detect spam, and assess quality. The system looks for signals that indicate expertise, authoritativeness, and trustworthiness, particularly for topics that could significantly impact people's lives. Medical content is evaluated for author credentials and citations of peer-reviewed research. Financial guidance is checked against regulatory standards and expert qualifications. News content is assessed for journalistic integrity and factual accuracy. The quality assessment process extends far beyond simple spam detection to encompass sophisticated understanding of content value and user intent. The system evaluates whether content provides genuine value to users or whether it's been created primarily to manipulate search rankings. It can detect automatically generated content, identify pages that are thin on valuable information, and recognize when content has been copied or slightly modified. This quality control isn't just about filtering out bad content, it's about ensuring that the best, most helpful, and most trustworthy information rises to the top. The algorithms consider factors like content depth and comprehensiveness, author expertise and credentials, website reputation and trustworthiness, and user engagement signals. This creates a merit-based system where high-quality content is rewarded with better visibility, while low-quality or manipulative content is filtered out or demoted. The indexing process also involves sophisticated language processing that goes far beyond simple keyword matching to understand the nuances, context, and cultural implications of human communication. Google's natural language processing systems can understand that bank means different things in different contexts, whether you're looking for financial institutions, riverbanks, or data storage concepts. They recognize that Jaguar could refer to the animal, the luxury car brand, or the operating system, depending on surrounding words and search context. This contextual understanding allows the system to index content not just by the words it contains, but by the concepts it represents. The system understands synonyms, related terms, and even implied meanings, allowing it to match user queries with relevant content even when exact words don't appear. Beyond basic language understanding, the indexing system performs sophisticated semantic analysis that creates connections between related concepts across the vast web of human knowledge. When processing a page about electric vehicles, the system understands this content relates to Tesla, battery technology, environmental sustainability, automotive industry, and hundreds of other connected concepts. These semantic relationships are stored as part of the index, allowing Google to provide comprehensive search results that include related information users might not have requested. This semantic web of understanding means that a search for climate change might surface relevant information about renewable energy, carbon emissions, environmental policy, and scientific research. The system builds vast knowledge graphs that map the relationships between people, places, organizations, events, and ideas, creating an interconnected understanding. The scale of Google's indexing operation challenges our ability to comprehend the magnitude of information processing involved in making the web searchable. The system processes content in hundreds of languages, understanding not just the words and grammar of different languages, but their cultural contexts, idioms, and unique expressions. It handles content in every conceivable format: text documents, images, videos, audio files, PDFs, spreadsheets, presentations, and even content embedded within applications and databases. Each type of content requires specialized processing techniques to extract meaningful information and make it searchable. Videos are analyzed for visual content, audio tracks, and even automatically generated transcripts. Images are processed for visual elements, text content through optical character recognition, and contextual information from surrounding web page content. This multi-format, multilingual processing creates a truly comprehensive index of human knowledge that spans every type of media and every language used on the web. The technical architecture supporting this massive indexing operation represents one of the most sophisticated distributed computing systems ever created. The system operates at a scale that processes more information every day than entire civilizations created throughout most of human history. The index itself is distributed across thousands of servers in multiple data centers around the world, with each server containing portions of the complete index. The system maintains multiple copies of critical index data to ensure that hardware failures or network problems don't result in lost information or degraded search performance. Load balancing systems automatically distribute processing work across available servers, ensuring that no single machine becomes overwhelmed while others sit idle. This distributed architecture allows Google to handle billions of search queries daily while simultaneously processing new content and updating existing index entries with fresh information. The indexing system also maintains sophisticated versioning and update mechanisms that ensure the search index stays current with the rapidly changing web. When content on a web page changes, the system doesn't just replace the old version, it understands what has changed and updates only the relevant portions. This incremental updating process is crucial for maintaining search freshness while managing the enormous computational resources required to keep the index current. The system tracks not just what content exists, but when it was created, how frequently it changes, and what those changes might mean for search relevance. This temporal understanding allows Google to balance the need for fresh information with the value of stable, authoritative content that remains relevant over time. Finally, the indexing process includes sophisticated preparation for the actual search and retrieval phase, pre-computing many of the calculations and relationships that will be needed. Rather than calculating everything from scratch for each query, the system pre-processes much of the analysis, creating optimized data structures for lightning-fast search responses. This preparation includes computing relevance scores for different term combinations, identifying authoritative sources for different topics, and creating cached versions of common search results. The system also prepares specialized indexes for different types of searches, such as image search, news search, local search, and shopping search. The result of all this processing is a search index that represents the culmination of human knowledge, perfectly organized and instantly accessible. Chapter 4: The Mind Reader, Query Processing and Digital Telepathy. Your search query has been submitted, cleaned, and normalized, but now it enters the most remarkable phase of the entire search process. This is the moment when Google's systems attempt to read your mind through nothing more than a few typed words. This is where artificial intelligence meets human curiosity in a dance of digital telepathy that would seem like pure magic to previous generations. The query processing systems don't just analyze what you've written, they decode your intentions, understand your context, and anticipate your needs with mind-reading accuracy. These systems have learned from analyzing trillions of searches performed by billions of people, creating a form of collective intelligence about human information seeking behavior. This collective intelligence can predict what you want to know before you fully understand it yourself. This isn't just pattern matching or keyword analysis, it's sophisticated psychological and linguistic understanding. The system considers your location, your history, your device, the time of day, current events, and countless other factors. All these factors build a comprehensive picture of what information will best serve your needs at this exact moment in time. When your processed query reaches Google's analysis engines, it encounters systems that know more about search behavior than any human psychologist knows about human nature. These analysis systems have been trained on more examples of human curiosity than exist in all the research libraries of the world combined. These analysis systems examine your query in the context of millions of data points, building a multidimensional understanding of your search intent. The system considers not just what you've typed, but who you are as a searcher, and what kind of answer is most likely to satisfy your specific information need. Your location matters enormously if you shared it, because a search for football means something entirely different in London versus Dallas. The system understands these cultural and geographical nuances with remarkable sophistication. Your search history provides crucial context, helping the system understand your typical interests, expertise level, and preferred types of content. The time of day influences interpretation, as the same query might have different urgency levels depending on whether you're searching at noon or midnight. The system understands that a search for Jaguar could refer to dozens of different things, but context analysis helps determine which interpretation is most likely correct for you specifically. Are you a car enthusiast looking for information about the luxury vehicle brand? A wildlife lover interested in the big cat? A software developer working with the Jaguar development environment? Or perhaps a sports fan looking for information about the Jacksonville Jaguars football team? The context analysis considers your previous searches, your geographic location, the device you're using, and even trending topics to make an educated guess. This disambiguation process happens instantly and invisibly, but it represents some of the most sophisticated artificial intelligence ever deployed. The system understands human language with nuance that rivals human comprehension. The system maintains detailed models of how different types of users search for different types of information, allowing it to customize its understanding. Modern search has evolved far beyond simple keyword matching into a realm of conceptual understanding that recognizes the fluidity and creativity of human language. Google's semantic matching systems understand that language is imprecise, that people express the same ideas in countless different ways. The exact words in a query might not match the exact words in the most relevant content. When you search for "fix my car," the system understands this is conceptually identical to automobile repair services, vehicle maintenance, and automotive troubleshooting. This semantic understanding is powered by advanced machine learning models that have learned the relationships between words, phrases, and concepts. These models analyze how language is actually used by real people in real contexts. The system understands that quick and fast are synonyms, that doctor and physician refer to the same profession, and that Big Apple means New York City. These relationships aren't explicitly programmed anywhere. They emerge from patterns in how humans actually use language. The matching process uses sophisticated techniques that go far beyond simple word association to understand conceptual relationships and implied meanings. Vector space models represent words and concepts as points in multidimensional mathematical spaces where conceptually similar terms cluster together. Related ideas maintain consistent mathematical relationships. This allows the system to understand that king minus man plus woman equals queen, or that Paris minus France plus Italy equals Rome. This demonstrates mathematical understanding of conceptual relationships that mirrors human intuition about how ideas relate to each other. These vector representations are learned from vast amounts of text data, allowing the system to understand subtle relationships between concepts. The matching algorithms can identify relevant content even when it uses completely different vocabulary from your search query, as long as the underlying concepts align. Perhaps the most impressive aspect of modern query processing is Google's ability to understand you as an individual searcher. The system builds what amounts to a digital personality profile that helps customize search results to your specific needs and preferences without compromising your privacy. This personalization system operates like having a research assistant who knows your interests, understands your expertise level, and can anticipate what type of information you find useful. The system develops nuanced understanding of whether you typically prefer technical, detailed information or simple explanations. It learns whether you're more likely to want recent news or comprehensive reference material, whether you prefer video content or written articles. The system understands what level of expertise you typically demonstrate in different subject areas. When a software developer searches for Python, the personalization system understands they probably want programming documentation and code examples. The same query from someone with a history of wildlife searches probably indicates interest in the snake. This isn't intrusive surveillance. It's helpful customization that makes search more efficient and relevant. The personalization extends to incredibly subtle patterns in search behavior that reveal preferences you might not even be consciously aware of yourself. The system learns your typical query complexity and sophistication level, understanding whether you usually ask simple questions or complex multi-part queries. It recognizes your preferred content depth, whether you typically want quick answers or comprehensive information that you can study in detail. The system understands your browsing patterns after clicking on search results, learning whether you typically spend time reading entire articles or scan for facts. It recognizes temporal patterns in your search behavior, understanding whether you're a morning researcher who likes to dive deep or an evening searcher looking for quick answers. All of this behavioral understanding is used to customize not just which results you see, but how they're formatted and presented. The query processing system also performs what can only be described as linguistic archaeology. The system digs deep into the structure and hidden meanings of human language to understand not just what you've written explicitly, but what you've left unsaid. Modern natural language processing models like BERT, MUM, and their successors represent breakthrough achievements in machine understanding of human language. These systems are capable of grasping context, ambiguity, and nuance in ways that were impossible just a few years ago. These systems understand that language is fundamentally contextual, that the meaning of words depends heavily on surrounding words, previous statements, and shared cultural understanding. They can handle implied relationships with remarkable accuracy, understanding that Obama wife refers to Michelle Obama, even though the grammatical connection isn't explicitly stated. They understand that iPhone charger refers to a lightning cable without needing to specify the connector type. These advanced language models can process conversational queries that would have completely baffled earlier search systems. They can handle natural language questions like, "What's that song that goes da-da-da-da?" by matching rhythm patterns against music databases. They can understand complex multi-part questions like, "Show me restaurants near the hotel I stayed at last month that serve the kind of food I ordered when I was in Italy." The system can maintain context across multiple related queries, understanding when you ask a follow-up question like, "What about organic options?" You're referring to your previous search about fertilizers or restaurants or whatever topic you were just exploring. This conversational understanding transforms search from a series of independent lookup operations into a collaborative research partnership between human curiosity and artificial intelligence. The system can even understand and respond appropriately to queries that contain errors, slang, regional dialects, or incomplete information. Behind all this linguistic sophistication lies a process that can only be described as digital pattern recognition, operating on a scale that defies human comprehension. Google systems continuously learn from the collective behavior of billions of users worldwide, identifying patterns in how people search, what results satisfy their information needs. They understand how different types of queries relate to different types of useful responses. When thousands of people search for iPhone battery and then consistently refine their searches to iPhone battery replacement or iPhone battery life problems, the system learns. Battery replacement information and troubleshooting guides should be more prominent in initial iPhone battery results. This collective intelligence creates a powerful feedback loop where every search performed by every user makes the system incrementally smarter and more helpful. The pattern recognition extends far beyond simple keyword associations to complex behavioral understanding that reveals the hidden structure of human information needs. The patterns discovered through this massive behavioral analysis extend to sophisticated understanding of how different types of people search for different types of information. The system learns that people searching for medical symptoms often follow up with searches for doctors in their area. Those researching vacation destinations typically want information about hotels, restaurants, and activities. Users looking up movie information frequently want to know where they can watch or stream that content. These behavioral insights allow Google to anticipate related information needs, sometimes providing answers to questions you didn't even know you had. The system can detect seasonal patterns, understanding that searches for flu symptoms, spike in winter months, tax preparation, becomes critical in early spring. This temporal intelligence helps the system prepare for predictable search patterns and adjust result priorities based on time-relevant factors. The query processing system also performs sophisticated intent classification that goes far beyond simple categorization to understand the complex motivations behind human information seeking. The system recognizes dozens of different search intents, from simple fact-finding to complex research projects, from immediate purchase decisions to long-term planning activities. A search for chest pain is understood as a potential medical emergency requiring immediate, authoritative health information. Chest exercises is recognized as a fitness query that might benefit from video demonstrations and workout routines. The intent classification considers not just the words in your query, but the time of day, your search history, current events, and seasonal patterns. The system understands that the same words can have dramatically different intents depending on context, and it adjusts its response accordingly. Your query also undergoes sophisticated semantic expansion, where Google's algorithms identify related concepts, alternative phrasings, and conceptually connected information. This information might contain relevant answers to your question, even if that information doesn't contain your exact search terms. This isn't simple synonym matching, it's deep conceptual understanding based on how language is actually used by real people in real contexts. When you search for car maintenance, the system understands. This relates not just to obvious synonyms like automobile service and vehicle repair. It relates to specific activities like oil changes, tire rotation, brake inspection, and transmission service, even though your query doesn't mention these specific procedures. The semantic expansion allows Google to cast a wide net for relevant information while maintaining precision in results. The processing system maintains vast, continuously updated knowledge graphs that map the intricate relationships between concepts. The system understands that Apple, the company, connects to iPhone, Steve Jobs, Tim Cook, Silicon Valley, technology, and thousands of other related concepts. Meanwhile, Apple, the fruit, connects to entirely different networks involving orchards, nutrition, recipes, farming, health, and cooking. These conceptual maps enable remarkably sophisticated matching between user queries and relevant content, allowing the system to find information that's conceptually relevant. The knowledge graphs understand not just simple associations, but complex relationships like cause and effect, part and whole, category membership, and temporal sequences. This semantic understanding allows search to provide comprehensive, contextually relevant results that address not just the literal question you asked, but the broader information need that motivated your search. Finally, the processing system performs sophisticated temporal and cultural analysis that ensures search results are not just relevant and authoritative, but also appropriate for your time and place. The system understands that different types of information have different lifespans and relevance windows, automatically detecting when queries require real-time information versus historical content. A search for stock market obviously needs current financial data, while how to change a tire can be satisfied with well-made instructional content regardless of publication date. The cultural analysis ensures that results are appropriate for your geographic location and cultural background. Football means different sports in different countries. Legal advice must be specific to relevant jurisdictions, and cultural references might not translate across regions. The system also considers current events and trending topics, understanding when breaking news or viral content might be relevant to your search. This comprehensive contextual understanding ensures that search results are not just accurate and relevant, but perfectly suited to your specific needs at this particular moment. Chapter 5, The Grand Ranking, where algorithms decide digital fate. Millions of web pages now compete for your attention in what can only be described as the ultimate digital competition. This is the technological colosseum where algorithms act as the most sophisticated judges ever created, evaluating countless pieces of content in milliseconds. These algorithms determine which pages deserve the coveted top positions in your search results. This is where the true magic of search happens, where Google's ranking systems sift through the vast treasure trove of indexed information. The ranking process represents one of the most complex decision-making systems ever devised, considering hundreds of different factors simultaneously. These systems create a personalized hierarchy of information that serves your unique needs. These aren't simple popularity contests or random selections. They're sophisticated evaluations that consider content quality, source authority, user experience, freshness, and countless other signals. The ranking systems ensure that the information reaching you represents the best that human knowledge has to offer. In this digital arena, only the most valuable content survives the algorithmic scrutiny to earn a place in your search results. At the heart of Google's ranking system lies PageRank, the revolutionary algorithm that treats the web like a democracy, where links function as votes of confidence. The crucial understanding is that not all votes carry equal weight. Created by Google's founders, Larry Page and Sergey Brin, PageRank fundamentally changed how we think about information authority. PageRank recognizes that a recommendation from a highly respected source carries more influence than recommendations from unknown entities. The algorithm evaluates web pages based on both the quantity and quality of other pages linking to them, but it goes far deeper than simple vote counting. A single link from a highly authoritative site like Harvard University, the Mayo Clinic, or the New York Times carries significantly more weight. This single authoritative link outweighs dozens of links from personal blogs or newly created websites. This creates a complex web of digital authority that helps identify the most trustworthy and valuable content on any given topic. The system understands that authority is contextual. A link from a medical journal carries more weight for health information than for cooking recipes. Meanwhile, a link from a renowned chef's website would be more valuable for culinary content. PageRank operates on the principle that authority flows through the web like water through a network of connected pipes. Each link transfers some of the source page's credibility to the destination. The algorithm doesn't just count links, it traces the entire network of connections to understand the broader context of authority and influence. A page that receives links from multiple authoritative sources in related fields accumulates significant ranking power. Pages that mainly receive links from unrelated or low-quality sources gain little benefit. The system also considers the anchor text of links, the words used to describe the linked content, as additional signals about the destination page. This link-based authority system creates a natural quality filter where genuinely valuable content tends to accumulate recommendations from other valuable sources. This creates a virtuous cycle that helps the best information rise to the top of search results naturally. While PageRank establishes the fundamental authority structure of the web, content relevance algorithms work like sophisticated literary critics. These algorithms determine how well each page matches your specific search query. These systems employ advanced mathematical techniques, including TF-IDF, term frequency, inverse document frequency, and BM25, to calculate precise relevance scores. The algorithms don't just count how many times your search terms appear on a page. They analyze the context, placement, and relationships of those terms to understand whether the page is truly about what you're looking for. A page that mentions your search term once in a highly relevant, authoritative context might rank higher than a page that repeats your keywords dozens of times without meaningful context. The system evaluates where keywords appear, with terms in headlines, subheadings, and opening paragraphs, generally carrying more weight than those buried in footnotes or sidebars. It also considers keyword proximity and co-occurrence, understanding that pages where your search terms appear close together and in meaningful relationships are more likely to be relevant. The relevance algorithms also perform sophisticated semantic analysis that understands the conceptual relationships between your search terms and the content on each page. The system recognizes that a page about automobiles might be highly relevant to a search for cars, even if it never uses the word car. Content about myocardial infarction is relevant to searches for heart attack, despite the completely different terminology. This semantic understanding allows the algorithms to find the most relevant content regardless of the specific vocabulary used. The system maintains vast databases of synonyms, related terms, and conceptual relationships that help it understand when content is topically relevant, even without exact keyword matches. In recent years, Google has revolutionized its ranking system by incorporating user experience signals directly into the algorithm. The system recognizes that truly helpful content must also be accessible, fast, and user-friendly. The Core Web Vitals initiative represents a fundamental shift toward measuring and rewarding technical quality alongside content quality. These metrics evaluate how quickly pages load, how stable they remain during the loading process, and how responsive they are to user interactions. The system ensures that high-ranking pages provide excellent experiences across all devices and connection speeds. Loading speed has become particularly crucial in an era where users expect instant access to information. Even delays of a few seconds can significantly impact user satisfaction. The system measures not just initial page load times, but also how quickly users can interact with content. Pages must become usable as quickly as possible, rather than forcing users to wait for complete loading before they can engage with the information they need. Mobile friendliness has evolved from a nice-to-have feature to an essential ranking factor, reflecting the reality that more searches now happen on smartphones than desktop computers. Google's mobile-first indexing means that the mobile version of websites becomes the primary version for ranking purposes, with desktop versions serving as secondary considerations. The algorithms evaluate whether text is readable without zooming, whether links and buttons are appropriately sized for touch interaction. They also check whether content adapts properly to different screen sizes and orientations. Sites that provide poor mobile experiences, regardless of their content quality, find themselves at a significant disadvantage in search rankings. This mobile-first approach has fundamentally changed web design and development practices, encouraging creators to prioritize user experience across all device types. Security has also become a crucial ranking factor, with HTTPS encryption now considered a baseline requirement rather than an optional enhancement. The algorithms favor secure websites that protect user privacy and data transmission, reflecting Google's broader commitment to making the web safer for everyone. Sites that still rely on unencrypted HTTP connections face ranking penalties, encouraging website owners to implement proper security measures. This security-focused approach extends beyond simple encryption to include protection against malware, phishing attempts, and other security threats. The system continuously monitors websites for security issues and can quickly demote or remove sites that pose potential risks to user safety. For topics that could significantly impact people's health, finances, safety, or overall well-being, Google employs particularly stringent evaluation criteria. These your money or your life topics receive special scrutiny because inaccurate or misleading information could cause real harm to people's lives. Google uses EEAT, experience, expertise, authoritativeness, and trustworthiness evaluation criteria that go far beyond traditional ranking factors. Medical content is evaluated not just for accuracy and completeness, but for author credentials. The system gives preference to content created by licensed medical professionals, reviewed by medical experts, or published by established healthcare institutions. The algorithms look for evidence of medical expertise such as board certifications, medical degrees, hospital affiliations, and citations of peer-reviewed research. Content that makes medical claims without proper credentialing or scientific backing faces significant ranking challenges. This ensures that users receive health information from qualified, trustworthy sources. Financial advice receives similar scrutiny, with algorithms evaluating whether content creators have relevant financial qualifications, regulatory compliance, and transparent disclosure of potential conflicts of interest. Investment advice, tax guidance, insurance recommendations, and other financial topics are assessed for author expertise and institutional backing. The system looks for credentials such as CPA certifications, financial advisor licenses, and affiliations with established financial institutions. Legal advice faces similar evaluation, with preference given to content from licensed attorneys, established law firms, and legal organizations. This expertise-based ranking ensures that when people search for information that could significantly impact their lives, they receive guidance from qualified professionals. The EEAT evaluation extends beyond individual author credentials to assess the overall trustworthiness and reputation of publishing websites. The algorithms consider factors such as editorial oversight, fact-checking processes, correction and update policies, and transparency about funding sources and potential biases. News organizations are evaluated for journalistic integrity, with preference given to outlets with established editorial standards, clear correction policies, and transparent reporting processes. The system can identify and reward organizations that demonstrate consistent accuracy and reliability over time, while demoting sources that repeatedly publish misleading or inaccurate information. This reputation-based assessment helps ensure that authoritative, trustworthy sources maintain their ranking advantages, while unreliable sources face appropriate penalties. Freshness represents another crucial ranking dimension, with algorithms sophisticated enough to understand when recency matters and when evergreen content serves users better. For breaking news, sports scores, stock prices, weather information, and trending topics, freshness becomes the most important ranking factor. Newer content receives significant preference over older information, regardless of other quality signals. The algorithms can detect when events are developing rapidly and automatically adjust ranking preferences to prioritize the most recent, accurate reporting. However, the system also recognizes when topic stability makes older, more comprehensive content more valuable than newer, but less thorough coverage. A detailed, well-researched article about historical events or scientific principles might maintain high rankings for years. Breaking news articles lose relevance within hours or days of publication. The freshness algorithms also understand seasonal and cyclical patterns in information needs, automatically adjusting ranking preferences based on temporal relevance. Content about tax preparation naturally becomes more prominent during tax season, while information about holiday celebrations gains relevance as those holidays approach. The system can predict and prepare for these cyclical information needs, ensuring that seasonally relevant content receives appropriate ranking boosts. This temporal intelligence extends to understanding how different types of queries have different freshness requirements, with some topics requiring constant updates while others remain valuable indefinitely. Machine learning has revolutionized Google's ranking systems through algorithms that can identify quality and relevance patterns too complex for human-designed rules to capture effectively. These neural networks, trained on vast data sets of search queries and user behavior, can recognize subtle indicators of content quality that traditional algorithms might miss. The machine learning systems analyze how users interact with search results, identifying patterns that indicate satisfaction or dissatisfaction with different types of content. Pages that consistently satisfy user information needs, as evidenced by long engagement times, low bounce rates, and positive user behavior signals, receive ranking benefits. Conversely, content that fails to meet user expectations faces gradual ranking declines, as the algorithms learn from collective user behavior. The machine learning systems also excel at detecting manipulative or low-quality content that might initially appear legitimate to rule-based algorithms. They can identify subtle patterns in content creation, linking strategies, and user engagement that indicate attempts to game search rankings rather than provide genuine value. This includes detecting AI-generated content that lacks human insight, identifying link schemes designed to artificially boost authority, and recognizing content farms. The machine learning approach allows Google systems to stay ahead of increasingly sophisticated manipulation attempts while rewarding genuine quality and user value. Real-time ranking adjustments represent one of the most impressive aspects of modern search algorithms. Systems are capable of updating rankings instantly based on developing events, changing user behavior patterns, and new information becoming available. When breaking news occurs, the algorithms can identify authoritative coverage within minutes and promote it in relevant search results. This happens before traditional editorial processes could even recognize the story's importance. This real-time capability extends to understanding when established facts change, when new research contradicts previous understanding, or when user preferences shift in response to current events. The system can quickly promote or demote content based on developing situations, ensuring that search results remain current and relevant even in rapidly changing circumstances. The ranking algorithms also perform continuous quality assessment, constantly re-evaluating content as new information becomes available about its accuracy, usefulness, and user satisfaction. Pages that initially rank well but later prove to be inaccurate, outdated, or unhelpful gradually lose ranking position as user behavior and external signals provide feedback. Conversely, content that demonstrates lasting value through sustained user engagement and expert recognition can improve its rankings over time. This dynamic assessment means that search result quality improves continuously, with the algorithms learning from every user interaction to refine their understanding. The competitive nature of search ranking creates powerful incentives for content creators to focus on genuine user value rather than short-term manipulation tactics. Because the algorithms reward content that truly satisfies user information needs, the most successful long-term strategy involves creating comprehensive, accurate, well-researched content. This creates a virtuous cycle where the pursuit of high search rankings naturally aligns with the creation of high-quality information resources. The ranking competition encourages innovation in content creation, user experience design, and information presentation, driving continuous improvements in the overall quality of information available. Finally, the ranking system operates with remarkable sophistication in balancing multiple, sometimes competing factors to create result sets that serve diverse user needs and preferences. The algorithms must weigh authority against freshness, comprehensiveness against accessibility, expert knowledge against practical utility, and global relevance against local applicability. This balancing act happens instantly for every search query, with the system creating customized ranking hierarchies that reflect both the specific information need and the broader context. The result is a search experience that feels natural and intuitive to users, even though it's powered by some of the most complex, algorithmic decision-making systems ever created. Your search results represent the outcome of this massive computational competition, where millions of web pages have been evaluated, compared, and ranked. The final results present you with the most valuable information available on your topic of interest. Chapter 6: The AI Revolution. Search in the Age of Artificial Intelligence. We are witnessing the most significant transformation in search since the invention of the Internet itself. This is a revolution so profound that it fundamentally changes not just how we find information, but how information finds us, and how knowledge is created. This is the age of artificial intelligence in search, where traditional lists of blue links are giving way to comprehensive, synthesized answers. These answers feel like having conversations with the world's most knowledgeable assistant. The AI revolution in search represents more than just an incremental improvement. It's a complete reimagining of what search can and should be. We live in an era where artificial intelligence can understand, reason, and create in ways that were pure science fiction just a few years ago. Google's integration of advanced AI systems like Gemini, BERT, and MUM has transformed search from a tool that helps you find existing information into one that can synthesize new insights. These systems can answer complex questions that have never been asked before and provide personalized explanations tailored to your specific level of understanding and context. This isn't just about better search results, it's about creating a new form of human-AI collaboration where your curiosity meets artificial intelligence capable of understanding and responding. Google's AI overviews represent perhaps the most visible and transformative aspect of this AI revolution, fundamentally shifting search from a discovery process to a comprehension process. Instead of presenting you with a list of websites to visit and information to piece together yourself, AI overviews synthesize information from multiple sources. These overviews provide comprehensive, coherent answers that directly address your questions. This is like having a research assistant who has read everything available on your topic and can provide you with a personalized briefing. The briefing combines the most relevant and accurate information from dozens or hundreds of sources. The AI doesn't just copy and paste information from websites, it understands the content, identifies the most relevant and credible information, and resolves contradictions between sources. The AI evaluates the quality and reliability of different claims and presents everything in a coherent, easy-to-understand format. Each statement in the overview is carefully attributed to its original sources, maintaining transparency and allowing you to dive deeper into any aspect that interests you. The sophistication of AI overviews goes far beyond simple summarization to include genuine understanding and reasoning about complex topics. When you ask about climate change, the system doesn't just find articles about global warming. It understands the scientific consensus, identifies the most credible research, explains the mechanisms and evidence, addresses common misconceptions, and presents the information appropriately. The AI can handle nuanced topics that require balancing multiple perspectives, synthesizing information from different fields of knowledge, and explaining complex cause and effect relationships. It can take a question like, "Why are housing prices so high?" and provide an answer that draws from economics, demographics, policy analysis, historical trends, and local market conditions. This provides you with a comprehensive understanding that no single website could provide. At the heart of this AI transformation lies Google's Gemini AI model, a multimodal artificial intelligence system that represents a quantum leap forward in machine understanding. Gemini doesn't just process text like earlier AI systems. It can understand and analyze images, videos, audio, and text simultaneously. This creates a unified understanding of information that mirrors how humans naturally process multiple types of input. This multimodal capability enables revolutionary search experiences where you can upload a photo of a broken appliance and ask, "How do I fix this?" You receive step-by-step repair instructions that are specifically relevant to the exact model and problem shown in your image. The AI can analyze visual symptoms, identify specific parts and components, cross-reference repair manuals and troubleshooting guides, and provide personalized instructions. These instructions address your exact situation rather than generic advice. Gemini's multimodal understanding extends to incredibly sophisticated analysis of complex visual and textual information working together. You can show it a graph or chart and ask it to explain the trends, implications, and significance of the data in plain language. You can upload a photo of a math problem and receive not just the solution, but a step-by-step explanation of the reasoning and techniques involved. The system can analyze historical photographs and provide detailed context about the time period, location, people, and significance of what's shown. This represents a fundamental shift from search engines that could only process text queries to AI systems that can understand and respond to the full spectrum of human communication. The conversational evolution of search represents another transformative aspect of the AI revolution, turning search from a series of individual queries into ongoing dialogues. Context and understanding build over multiple exchanges. Modern AI-powered search can maintain memory of your conversation, understand when you're asking follow-up questions, and build upon previous exchanges to provide increasingly sophisticated assistance. When you ask, "What's the best camera for landscape photography?" and then follow up with, "What about something more budget-friendly?" or "How does that compare to mirrorless options?" The AI understands that you're continuing the same conversation and tailors its responses accordingly. This conversational ability transforms search from a lookup tool into a research partner that can help you explore complex topics through natural dialogue. This conversational sophistication allows for incredibly nuanced interactions where the AI can ask clarifying questions, suggest related topics you might want to explore. The AI adapts its communication style to match your preferences and expertise level. If you're researching a complex scientific topic, the AI can start with a basic explanation and then dive deeper based on your follow-up questions and apparent understanding. If you're looking for practical advice, it can focus on actionable recommendations rather than theoretical background. The system learns your communication patterns and preferences throughout the conversation, becoming a more effective research partner as the dialogue progresses. The natural language processing capabilities that power these AI search experiences represent some of the most advanced artificial intelligence ever deployed at scale. These systems are capable of understanding not just the literal meaning of your words, but the intent, context, and nuance behind your questions. These systems can handle ambiguous queries, understand implied information, interpret cultural references, and even detect emotional context that might influence what kind of answer would be most helpful. When you search for "I can't sleep," the AI understands this might be about medical concerns, lifestyle advice, immediate solutions, or long-term strategies. It can provide comprehensive information that addresses multiple potential aspects of your concern while prioritizing the most immediately helpful guidance. The advanced language models can also handle incredibly complex, multi-part questions that would have been impossible for traditional search systems to process effectively. You can ask something like, "Compare the environmental impact of electric cars versus hybrid cars for someone who drives 50 miles per day in a city with coal-powered electricity." You receive a comprehensive analysis that considers all the specific factors you've mentioned. The AI can perform complex reasoning that takes into account multiple variables, trade-offs, and contextual factors to provide answers that are specifically relevant to your unique situation. Visual search and multimodal queries represent another frontier where AI is revolutionizing how we interact with search technology. Google Lens and similar AI-powered visual search tools allow you to point your camera at objects, text, or scenes and receive instant information about what you're seeing. You can photograph a plant and learn its species, care requirements, and potential problems. You can capture an image of text in a foreign language and see it translated in real time. You can take a picture of a landmark and receive historical information, visitor guides, and related recommendations. This visual search capability extends to complex analysis, where the AI can identify problems, suggest solutions, and provide guidance based on what it sees in images. The visual understanding goes far beyond simple object recognition to include contextual analysis and reasoning about what images mean and represent. The AI can look at a photo of your garden and provide specific advice about plant health, soil conditions, spacing issues, and seasonal care. It can analyze architectural photos and provide information about styles, periods, materials, and design principles. This visual intelligence transforms how we can seek information about the physical world around us, making expert knowledge accessible through simple camera interactions. AI-powered search also excels at handling hypothetical and creative queries that traditional search systems couldn't address effectively. You can ask, what if the internet had been invented in the 1800s, and receive thoughtful analysis of how different technological, social, and economic conditions might have influenced development. The AI can engage in creative reasoning, draw parallels from historical examples, and explore implications and possibilities that require genuine intellectual creativity. This capability opens up entirely new categories of questions and explorations that were previously impossible to address through search. The real-time analysis and synthesis capabilities of AI search systems allow them to provide up-to-date information and analysis that adapts instantly to changing circumstances. During breaking news events, AI systems can synthesize information from multiple reliable sources, identify key facts and developments, distinguish confirmed information from speculation. They provide comprehensive summaries that help users understand rapidly evolving situations. This real-time capability extends to personal queries, where the AI can consider current conditions, recent changes, and trending information to provide advice and recommendations perfectly timed for your specific situation. Personalization in AI search reaches unprecedented levels of sophistication, where the systems don't just remember your search history, but understand your interests, expertise level, communication preferences, and goals. This allows for truly customized information experiences. The AI can adapt not just what information it provides, but how it explains concepts, what examples it uses, what level of detail it includes. It also adapts what follow-up information might be most valuable for your specific needs and interests. This personalization happens dynamically during conversations, with the AI learning about your preferences and knowledge level through your questions and responses. The integration of AI into search also enables powerful fact-checking and source evaluation capabilities that help users navigate an increasingly complex information landscape. AI systems can cross-reference claims against multiple authoritative sources, identify potential misinformation or outdated information, and provide context about the reliability and credibility of different sources. This capability becomes particularly valuable for controversial or rapidly changing topics where users need help distinguishing reliable information from speculation, bias, or deliberate misinformation. AI search systems also excel at making connections and identifying relationships between seemingly unrelated topics, providing insights and perspectives that might not be obvious from traditional approaches. The AI can identify patterns across different fields of knowledge, find unexpected connections between concepts, and suggest related topics or approaches that could provide additional valuable insights. This capability makes AI search particularly powerful for research, creative projects, and problem-solving applications where innovative connections and perspectives can be especially valuable. The educational potential of AI-powered search represents another transformative application, where the technology can serve as an infinitely patient tutor that adapts its teaching approach to individual learning styles. Students can ask questions at any level of complexity and receive explanations that are perfectly tailored to their current understanding and learning objectives. The AI can provide examples, analogies, and practice problems that help reinforce learning, and it can identify areas where students might need additional support or clarification. This educational capability extends to professional development and lifelong learning, where AI search can help people develop new skills and knowledge at their own pace. The creative applications of AI search are beginning to reveal entirely new possibilities for human creativity and expression. The AI can help brainstorm ideas, suggest creative approaches, provide inspiration from diverse sources, and even collaborate in creative projects by offering feedback and suggestions. Writers can explore character development and plot ideas, artists can discover new techniques and inspiration, and entrepreneurs can investigate market opportunities and business strategies. This creative collaboration represents a new form of human-AI partnership, where artificial intelligence enhances rather than replaces human creativity and insight. Privacy and ethical considerations in AI search represent ongoing challenges that require careful balance between personalization benefits and user privacy rights. Google and other companies are developing sophisticated privacy-preserving technologies that allow for personalized AI experiences while protecting user data and maintaining appropriate boundaries. These developments include techniques for processing queries without storing personal information, methods for providing personalized responses without building comprehensive user profiles, and approaches for maintaining user control. The future trajectory of AI in search points toward even more sophisticated capabilities, including improved reasoning and analysis, better understanding of complex multimodal inputs, more natural conversational abilities. We're moving toward AI search systems that can serve as comprehensive research assistants, creative collaborators, educational tutors, and problem-solving partners. These systems understand not just what we're asking, but what we're trying to accomplish, and how they can best support our goals and interests. Finally, the AI revolution in search represents a fundamental shift in the relationship between humans and information, from a model where we search for existing knowledge to one where we collaborate with artificial intelligence. This transformation has implications far beyond technology, potentially changing how we learn, how we work, how we solve problems, and how we understand and interact with human knowledge. The AI search revolution is not just changing how we find information, it's changing what becomes possible when human curiosity meets artificial intelligence capable of understanding, reasoning, and creating. Chapter 7: The Grand Presentation: Crafting the Perfect Search Results Page. Behind the scenes of every search query lies one of the most sophisticated presentation systems ever created. This is a digital theater where algorithms work like master directors to craft the perfect performance for each individual searcher. Your search results page isn't a random collection of links thrown together haphazardly, it's a carefully orchestrated presentation. It's designed to give you the most useful information in the most helpful format possible. Each element on the page, from organic results to featured snippets, from knowledge panels to image carousels, has been positioned with surgical precision. All of this creates an information experience that serves your specific needs and preferences. The Search Engine Results Page, or SERP, represents the culmination of everything we've explored so far. Crawled content, sophisticated indexing, intelligent query processing, and complex ranking algorithms all come together in a seamless user interface. This makes accessing human knowledge feel as natural as having a conversation. This is where Google's technological mastery transforms into human utility, where billions of data points become actionable information. The impossible complexity of organizing all human knowledge becomes the simple elegance of finding exactly what you need. The SERP assembly process operates like a master conductor, orchestrating a complex symphony where each element must be positioned precisely. This creates the most useful and coherent user experience possible. The system considers not just individual result quality, but how different components work together synergistically to serve your information needs. If there's a comprehensive featured snippet that completely answers your question, the system might include fewer traditional web results to avoid redundancy. If your query suggests you might want visual information, image and video results receive prominent placement near the top of the page. When you're searching for local services, map results and business listings take priority over general informational content. This intelligent composition creates results, pages that feel naturally organized and intuitively helpful. They're powered by incredibly complex decision-making systems that evaluate thousands of potential layouts and configurations in milliseconds. The orchestration extends to understanding the relationship between different types of content and how they can complement each other to provide comprehensive answers. A search about a historical event might combine traditional web results with image galleries, video documentaries, news coverage, and encyclopedia entries. All of this is arranged to tell a complete story rather than simply listing random information sources. The system understands that some queries benefit from diverse perspectives and multiple content types, while others are best served by focused authoritative sources. This content curation transforms search results from simple lists into rich information experiences that anticipate and address multiple aspects of your curiosity. Featured snippets represent Google's most ambitious attempt to provide instant, authoritative answers directly within search results. These eliminate the need to visit multiple websites for straightforward questions. These aren't simple copy and paste operations. They're sophisticated extractions where algorithms analyze web content to identify the most relevant information. The system formats this information for maximum clarity and usefulness. The system can create different types of snippets based on your query type and the nature of available information. Paragraph snippets for definitions and explanations, bulleted lists for step-by-step processes, numbered lists for rankings and procedures, and table snippets for comparative information. Each format is chosen based on which presentation style best serves your specific information needs, making complex information immediately accessible and actionable. The creation of featured snippets involves sophisticated natural language understanding that can identify the most relevant portions of longer content. The system extracts these portions while maintaining context and accuracy. When you search for how to change a tire, the system doesn't just find any mention of tire changing. It identifies comprehensive, step-by-step instructions from authoritative sources and formats them as clear, numbered procedures. The algorithms evaluate content for completeness, accuracy, and clarity, preferring sources that provide thorough, well-organized information from credible publishers. This content evaluation ensures that featured snippets provide genuinely helpful information rather than potentially misleading or incomplete fragments. Knowledge panels transform search results from collections of links into comprehensive information experiences. They present structured, authoritative data about specific entities, people, places, organizations, and concepts. These panels, powered by Google's Knowledge Graph, provide immediate access to key facts, relationships, and context. You don't need to visit multiple websites to piece together basic information. When you search for a celebrity, the Knowledge Panel provides biographical information, career highlights, recent projects, and related people. For a business, you'll see contact information, hours, reviews, and location details. Historical events receive comprehensive summaries with dates, key figures, and consequences. This structured presentation transforms search from a discovery process into an immediate knowledge experience. The knowledge panels are dynamically generated based on your specific query and context, emphasizing information that's most relevant to your apparent interest. A search for Einstein might emphasize his scientific contributions, if your search history suggests in physics, but it might highlight his philosophical quotes and personal life if your queries typically focus on biographical and cultural topics. The system curates information to match your apparent level of interest and expertise, providing accessible overviews for general audiences. It includes more detailed technical information for users who demonstrate specialized knowledge in relevant fields. Rich results and structured data integration create visually appealing and functionally useful search experiences. These go far beyond simple blue links to provide actionable information directly within search results. Review styles for restaurants help you quickly identify highly rated dining options, Event dates and locations allow you to immediately determine if something fits your schedule. Product prices and availability help you make purchasing decisions without visiting multiple retailers. Recipe information, including cooking times and ratings, lets you find the perfect dish for your needs and skill level. This enhanced information comes from structured data markup that websites provide, creating a collaborative system. Content creators help search engines understand and present their information more effectively. The rich results system understands different types of content and presents each with appropriate formatting and emphasis. Entertainment content like movies and TV shows receives rich presentation with cast information, ratings, and streaming availability. Educational content gets enhanced with course information, prerequisites, and learning outcomes. E-commerce products are presented with pricing, availability, shipping information, and customer feedback. This content-aware presentation helps users quickly evaluate their options and make informed decisions. They don't need to visit individual websites to gather basic comparative information. Universal Search Integration represents one of Google's most significant innovations, seamlessly blending different types of content. Images, videos, news, maps, shopping results, and specialized databases combine into unified search experiences. These serve diverse information needs within single result sets. Instead of requiring separate searches for different types of media, Universal Search understands when different content types might be relevant to your query. A search for a travel destination might combine traditional web results with images of attractions, videos of local experiences, map information, hotel booking options, and current weather conditions. All of this is presented in a cohesive interface that serves multiple aspects of travel planning simultaneously. This integration requires sophisticated understanding of how different content types complement each other. The system learns from user behavior to understand when people want comprehensive multimedia experiences versus focused specific information. It adjusts the mix and prominence of different content types accordingly. News events receive immediate integration of text reports, images, videos, and social media content to provide comprehensive coverage of developing stories. Product searches combine shopping results, reviews, comparison information, and instructional videos to support informed purchasing decisions. Mobile-first design has fundamentally transformed how search results are presented, with Google now primarily designing for smartphone interactions before adapting for larger screens. This mobile-first approach recognizes that more searches now happen on phones than computers. This requires result presentations that work effectively on small screens with touch interfaces. Mobile search results prioritize the most essential information, use larger text and touch targets, minimize scrolling requirements, and optimize loading speeds for cellular connections. The presentation adapts dynamically to different screen sizes and orientations, ensuring that critical information remains accessible and actionable. The mobile optimization extends beyond simple responsive design to include fundamental changes in how information is prioritized and presented. Mobile users often want immediate, actionable information rather than comprehensive research materials. So mobile results emphasize quick answers, local information, contact details, and immediately useful data. The system understands that mobile searchers might be multitasking, in transit, or dealing with connectivity limitations. It prioritizes fast loading, essential information over comprehensive but slower loading resources. Real-time result generation represents one of the most impressive technical achievements in search. Systems are capable of assembling customized search result pages in milliseconds, while considering millions of potential results and dozens of presentation formats. Each search triggers dynamic evaluation of available content, ranking calculations, personalization factors, and presentation optimization. All of this happens faster than human perception can detect. The system simultaneously evaluates organic results, determines appropriate special features like snippets and knowledge panels, considers advertising relevance and placement, and optimizes the overall page layout. This real-time capability extends to incorporating breaking news, trending topics, and rapidly changing information into search results almost instantaneously. When major events occur, the search results system can reorganize and reprioritize content within minutes. This ensures that users searching for related information receive the most current and relevant coverage available. The system balances freshness with authority, promoting new information about developing stories while maintaining links to comprehensive background coverage. Personalization in search results. Presentation goes far beyond simple customization to include sophisticated adaptation of result types, information emphasis, and interface elements. This is based on your demonstrated preferences and behavior patterns. The system learns whether you typically prefer video content or written articles, whether you want quick answers or comprehensive information. It learns whether you're usually looking for local results or general information, and how you typically interact with different types of search features. This behavioral understanding allows the system to emphasize result types and information formats that you're most likely to find useful. It still provides access to alternative perspectives and content types. The personalization happens dynamically during each search, with the system making real-time decisions about which information to emphasize. It decides how to format results and which additional features might be most valuable for your specific query and context. Regular users of Google Shopping might see more prominent product results and pricing information. Those who frequently engage with news content receive more comprehensive news integration and source diversity. This adaptive presentation makes search results more efficient and relevant, while maintaining the breadth and diversity that makes search valuable for exploration. Advertising integration within search results represents a delicate balance between commercial relevance and user experience. Sophisticated systems ensure that promotional content enhances rather than detracts from the search experience. Search ads are subject to quality standards that evaluate relevance, usefulness, and user experience factors. This ensures that commercial results provide genuine value to users rather than simply generating revenue for advertisers. The ad ranking system considers not just advertiser bids, but click-through rates, user engagement, landing page quality, and overall user satisfaction. This determines which commercial results deserve prominent placement. The integration extends to understanding when commercial results serve user interests and when they might be intrusive or unhelpful. Product searches naturally benefit from shopping ads that provide pricing and availability information. Informational queries about health topics prioritize authoritative medical information over commercial promotion. The system continuously monitors user behavior and satisfaction signals to refine the balance between commercial and organic results. This ensures that advertising enhances rather than diminishes the overall search experience. Local search integration demonstrates how search results adapt to geographic context and location-based information needs. Results are not just topically relevant but also practically accessible and geographically appropriate. Local results consider your location, business hours, current weather, traffic conditions, and seasonal factors to provide information that's immediately actionable. Restaurant results include current hours, reservations availability, and estimated wait times. Service businesses show availability, contact information, and travel distances. Event listings consider your location for ticket availability and transportation options. The local integration extends to understanding regional preferences, cultural context, and local market conditions. These factors influence how information should be presented and what sources are most credible and useful for specific geographic areas. Legal information becomes jurisdiction-specific. Weather results focus on local conditions and forecasts, and news results emphasize local coverage and impact. This geographic awareness ensures that search results provide practical, actionable information rather than generic responses. Accessibility and inclusive design principles guide search result presentation to ensure that information remains accessible to users with diverse abilities, needs, and technological constraints. The results pages are designed to work effectively with screen readers, voice interfaces, and assistive technologies. Visual, auditory, and motor impairments don't create barriers to accessing information. High contrast modes, large text options, and keyboard navigation support help users customize the search experience to match their individual needs and preferences. The accessibility extends to considering diverse language abilities, literacy levels, and cultural backgrounds in how information is presented and explained. The system can provide simplified explanations for complex topics, offer multiple language options for multilingual users. It presents information in formats that accommodate different learning styles and information processing preferences. This inclusive approach ensures that search serves diverse global audiences rather than assuming universal technological access or educational background. Quality control in search result presentation involves continuous monitoring and optimization to ensure that the assembled result pages provide genuine value and positive user experiences. The system tracks user engagement, satisfaction signals, and behavior patterns to identify when result presentations are working effectively. Results pages that consistently lead to positive user outcomes receive reinforcement in the presentation algorithms. Layouts that generate user frustration or fail to meet information needs are automatically adjusted or replaced. Finally, the search results page represents the culmination of one of humanity's most ambitious technological projects. It's the democratization of access to all human knowledge through simple, intuitive interfaces that make finding information as natural as asking a question. Every element on your search results page, from the precise wording of result snippets to the positioning of images and videos, represents the outcome of sophisticated algorithmic decision-making. This is designed to serve your unique information needs as effectively as possible. The seemingly simple list of search results actually represents a personalized, dynamically generated, comprehensively optimized information experience. It draws from the entire corpus of human knowledge to provide you with exactly the information you need, precisely when you need it. The format is the one that will be most useful for your specific situation and goals. This transformation of infinite complexity into intuitive simplicity represents one of the greatest achievements in the history of information technology. It makes the accumulated wisdom of our species instantly accessible to anyone with curiosity and an internet connection. Chapter 8: The Learning Loop: How Your Clicks Shape Tomorrow's Search. Your interaction with search results isn't the end of the story, it's the beginning of Google's next learning cycle. This is a continuous feedback loop that transforms every click, every pause, every return to search results into valuable intelligence. This makes the system smarter for everyone. This is where the magic of machine learning meets human behavior in one of the most sophisticated behavioral analysis systems ever created. The collective wisdom of billions of users becomes algorithmic improvements that benefit the entire global community. Every time you click on a search result, spend time reading an article, or return to modify your search query, you're participating in history's largest collaborative intelligence project. Your individual actions, combined with similar behaviors from millions of other searchers, create patterns. These patterns reveal what truly satisfies human information needs, what disappoints users, and how search systems can better serve human curiosity. This isn't passive data collection, it's active collaboration between human intelligence and artificial systems. Your natural information-seeking behaviors become the training data that teaches machines to understand and serve human needs more effectively. The learning loop represents the democratization of search improvement, where every user becomes a teacher helping to refine and enhance the system for future searches. Every time you click on a search result, you're casting a vote in the world's largest ongoing election about information quality and relevance. You're participating in a continuous democratic process that shapes how future searches will be answered. Google's click-through analysis systems track not just which results people choose, but the complex patterns of selection that reveal user preferences, satisfaction levels, and information needs. The system understands that clicks aren't just binary choices, they're nuanced expressions of user intent that can be interpreted and learned from. When thousands of people consistently choose the third result over the first two for a particular query, the algorithms recognize that the ranking might not reflect actual user preferences. The system gradually adjusts the positioning to better match demonstrated user needs. This click-based feedback creates a self-improving system where search results become increasingly aligned with what real users actually find helpful and relevant. The system prioritizes what algorithmic predictions suggest should be useful. The sophistication of click analysis extends far beyond simple popularity metrics to include contextual understanding of why people make different choices in different circumstances. The system recognizes that click patterns vary based on query complexity, user expertise, time constraints, and information goals. A quick click followed by an immediate return might indicate that the result wasn't what the user expected. Longer engagement followed by related searches might suggest partial satisfaction that led to deeper exploration. The algorithms learn to distinguish between different types of clicking behavior, understanding when rapid clicking indicates efficiency versus frustration. They understand when longer engagement represents satisfaction versus confusion, and when return visits indicate value versus inability to find better alternatives. This nuanced understanding allows the system to improve not just result rankings, but result presentation, snippet quality, and overall user experience. Dwell time analysis provides another crucial dimension of user feedback, measuring not just where people click, but how long they spend engaging with different types of content. This reveals what that engagement tells us about information satisfaction. The system tracks how long users spend on different pages, understanding that optimal dwell time varies dramatically depending on query type and information need. A search for a phone number should result in a very brief visit that quickly provides the needed information. Research about a complex topic might require extended engagement with multiple sources. The algorithms learn to recognize healthy engagement patterns for different types of queries. They identify when short visits indicate successful information retrieval versus inadequate content, and when long visits represent valuable deep learning versus user confusion. This temporal analysis extends to understanding how user engagement patterns evolve during research sessions and across multiple related searches. The system can track how people move through research processes, identifying when users successfully find information that builds upon previous searches. It can identify when they get stuck in unproductive cycles. The dwell time data helps optimize not just individual result quality, but the sequencing and relationship between results that support complex, multi-step information needs. When users consistently spend significant time with certain combinations of results, the algorithms learn to present related information more prominently. Search refinement patterns reveal some of the most valuable insights about user satisfaction and system performance. They show how people modify their queries when initial results don't meet their needs. When users search for iPhone battery and then immediately refine their search to iPhone battery replacement, the system learns that battery replacement information should be more prominent in initial results. These refinement patterns create a continuous feedback loop where unsuccessful searches teach the system about gaps in understanding or result quality. This leads to improvements that reduce the need for query modification. The algorithms track not just individual refinements, but large-scale patterns across millions of users that reveal systematic issues or opportunities for enhancement. The analysis of refinement patterns extends to understanding the evolution of language and user expectations over time. As new terminology emerges, as cultural references change, and as technology evolves, user query patterns shift in ways that help the system stay current. The refinement data helps identify emerging trends, new ways of expressing familiar concepts, and changing user expectations about information depth and presentation. This linguistic evolution tracking ensures that search systems remain aligned with how people actually communicate, rather than becoming anchored to outdated patterns. Machine learning feedback loops transform individual user interactions into system-wide improvements through sophisticated algorithms. These algorithms can identify patterns too subtle for human analysts to detect. These neural networks analyze millions of user interactions simultaneously, finding correlations and insights that reveal how to better serve information needs across diverse user populations. The machine learning systems can identify when certain types of users consistently prefer different result formats. They can identify when specific query patterns indicate distinct information needs and when particular content presentations lead to higher user satisfaction. This pattern recognition operates at scales that would be impossible for human analysis. It processes behavioral data from billions of searches to extract actionable insights about search system optimization. The machine learning approaches excel at recognizing complex, multi-dimensional patterns that involve interactions between user characteristics, query properties, result features, and contextual factors. The systems can learn that users searching from mobile devices in the evening prefer different result formats than desktop users researching during work hours. They can learn that queries containing certain emotional indicators require different approaches than purely factual information requests. These nuanced pattern recognitions enable personalization and optimization strategies that account for the full complexity of human information behavior. Real-time adaptation capabilities allow the search system to incorporate user feedback and behavioral insights almost instantaneously. This creates dynamic responsiveness that can adapt to changing circumstances, emerging events, and evolving user needs within minutes or hours. When breaking news events generate new search patterns and information needs, the system can quickly identify what users are looking for. It can identify what sources are providing the most satisfactory coverage and how result presentation should adapt to serve rapidly evolving information requirements. This real-time learning extends to identifying and responding to seasonal patterns, cultural events, and trending topics that require immediate adjustments. The real-time capabilities also enable immediate quality control responses when user behavior indicates problems with search results or system performance. If users suddenly start showing signs of dissatisfaction with results for particular queries, the system can automatically investigate and adjust. It makes these adjustments before the problems affect large numbers of users. This responsive quality control helps maintain consistently high user satisfaction, even as content quality, website performance, and information landscapes change dynamically across the web. Behavioral pattern recognition systems analyze not just individual actions, but complex sequences of user behavior that reveal information, seeking strategies, research methodologies, and decision-making processes. The system learns to recognize when users are conducting comprehensive research versus looking for quick answers. It can identify when they're comparing options versus seeking specific information, and when they're exploring new topics versus deepening existing knowledge. These behavioral insights enable search optimizations that support different types of information, seeking behaviors with appropriate result formatting, content sequencing, and interface adaptations. The pattern recognition extends to identifying user expertise levels and information sophistication based on query patterns, result selections, and engagement behaviors. The system can recognize when users demonstrate advanced knowledge in particular fields versus when they're approaching topics as beginners. This enables result customizations that provide appropriate levels of technical detail, background context, and explanatory depth. This expertise recognition helps ensure that search results match user knowledge levels and learning objectives. Collective intelligence emerges from the aggregation of individual user behaviors into insights that benefit the entire global user community. This creates a system where everyone's search experiences contribute to improved results for everyone else. When users in one geographic region consistently prefer certain types of sources for particular topics, those preferences can inform result optimizations that benefit users worldwide. When particular demographic groups demonstrate distinct information needs or consumption preferences, those insights help create more inclusive and effective search experiences for diverse user populations. This collective learning creates network effects where the system becomes more valuable and effective as more people use it. Each user's behavior contributes to algorithmic improvements that enhance search quality for everyone. The collective intelligence system maintains careful privacy protections while extracting valuable behavioral insights. It uses advanced techniques like differential privacy and aggregation methods that learn from user patterns without compromising individual privacy. The system can identify broad behavioral trends and preferences without tracking or storing information about specific individuals. This enables population-level learning that improves search quality while respecting user privacy rights and expectations. Quality signal integration combines user behavior data with numerous other indicators of content quality and relevance. This creates comprehensive assessments of search result effectiveness that go beyond simple popularity metrics. The system correlates user satisfaction signals with expert evaluations, content quality indicators, source credibility measures, and factual accuracy assessments. This develops nuanced understanding of what makes information genuinely valuable versus merely appealing or widely shared. This multidimensional quality assessment helps ensure that algorithmic improvements driven by user behavior align with broader objectives of information, accuracy, reliability, and usefulness. The quality integration also helps identify and mitigate potential biases or manipulation attempts that might skew user behavior data. By combining behavioral signals with independent quality assessments, the system can distinguish between content that's genuinely helpful and content that might be engineered to generate engagement. This balanced approach helps ensure that user behavior feedback contributes to authentic improvements in search quality. Long-term learning cycles enable the search system to identify and respond to gradual changes in user expectations, information landscapes, and communication patterns. These changes might not be apparent from short-term behavioral analysis. The system tracks how user satisfaction with particular result types or content formats evolves over time. It identifies when changing technological capabilities or cultural expectations require adjustments to search result presentations or ranking priorities. These long-term insights help the system stay aligned with evolving user needs and expectations rather than becoming anchored to historical patterns. The long-term analysis also helps identify the lasting impact of system changes and improvements. It measures whether algorithmic adjustments lead to sustained improvements in user satisfaction and search effectiveness over extended periods. This longitudinal evaluation helps distinguish between changes that provide immediate but temporary improvements versus modifications that create lasting enhancements. Personalization learning systems use individual user behavior patterns to customize search experiences while maintaining privacy protections. They avoid creating restrictive filter bubbles that might limit information exposure. The system learns about individual preferences for result formats, information depth, source types, and presentation styles. It does this without creating detailed personal profiles that could compromise privacy or create inappropriate personalization boundaries. This balanced personalization enhances user experience through relevant customization while preserving the diversity and breadth that makes search valuable for exploration and discovery. The personalization learning also helps identify when individual users might benefit from different search approaches or result presentations. This is based on their demonstrated research patterns and information consumption behaviors. Users who consistently engage deeply with technical content might receive more detailed, specialized results. Those who prefer visual information might see enhanced image and video integration. This adaptive personalization creates more effective and satisfying search experiences while respecting individual privacy and maintaining appropriate information diversity. Satisfaction measurement systems employ sophisticated methodologies to assess user happiness and search effectiveness. These go beyond simple engagement metrics to include measures of task completion, information discovery success, and overall user experience quality. The system tracks whether users successfully find the information they were seeking. It tracks whether they discover valuable related information they weren't initially looking for, and whether their search experiences leave them feeling satisfied and confident. These satisfaction measurements provide crucial feedback about search system effectiveness that helps guide continued improvements and optimizations. The satisfaction measurement extends to understanding how search experiences contribute to user goals and outcomes beyond immediate information retrieval. It assesses whether search results help users make better decisions, learn new skills, solve problems, or accomplish meaningful objectives. This broader impact measurement helps ensure that search system optimizations contribute to genuine user value and life improvement. Algorithmic transparency and user agency considerations ensure that user behavior feedback systems operate ethically and respect user autonomy. They provide valuable insights for search improvement. Users maintain control over their data contribution to search improvement processes, with clear options to limit or opt out of behavioral analysis. They still receive high-quality search results. The system provides transparency about how user behavior contributes to search improvements while protecting individual privacy and maintaining trust. Finally, the learning loop represents one of the most remarkable examples of human AI collaboration in the modern world. Human intelligence and artificial systems work together to create continuously improving information access that serves the collective needs of global society. Every search you perform, every click you make, and every refinement you try contributes to a vast collaborative intelligence project. This makes information more accessible, relevant, and useful for everyone. This ongoing collaboration between human behavior and machine learning creates a search system that becomes smarter, more helpful, and more aligned with human needs. The learning loop ensures that search technology continues to evolve in response to changing human needs, emerging information landscapes, and new ways of seeking and consuming knowledge. This creates a dynamic system that grows more valuable and effective through continued use and collaborative improvement. Chapter 9: The Digital Infrastructure, the Invisible Foundation of Search. Behind every millisecond search response lies one of the most sophisticated technological infrastructures ever constructed by humanity. This is a global network of computing power that operates at a scale so vast it challenges our ability to comprehend the engineering marvel. This infrastructure makes instant access to human knowledge possible. When you press enter on your search query, You're not just accessing a single computer or even a single building full of servers. You're tapping into a distributed computing system that spans continents, connects through private fiber optic networks that circle the globe. This system operates with a level of coordination and reliability that would make the most complex orchestras seem simple by comparison. This invisible foundation represents one of the greatest engineering achievements in human history. It's a technological ecosystem that processes more information every day than entire civilizations created throughout most of human existence. The infrastructure that powers Google Search operates on a scale that defies intuitive understanding, involving millions of servers, thousands of engineers. It involves billions of dollars in technology investments, all coordinated with precision that makes split-second search responses feel as natural as flipping a light switch. This is the hidden world of data centers, network operations, and distributed computing that transforms your simple question into a global, computational event. Google's search infrastructure operates like a vast nervous system spanning the entire planet. Data centers are strategically positioned on every continent, connected by private fiber optic networks that carry information at the speed of light across oceans and continents. When you search, your query might be processed by servers in multiple countries simultaneously, with the results assembled and delivered from the location that can serve you fastest. This global distribution isn't just about speed, it's about resilience and reliability. It ensures that natural disasters, network outages, or equipment failures in one region don't disrupt search services for users worldwide. The system maintains multiple redundant pathways for every piece of data and every computational process. This creates a network so robust that it can continue operating even when significant portions of the infrastructure experience problems. The geographic distribution also enables localization and cultural customization, allowing search results to reflect regional preferences, language variations, and local information needs. Each of Google's data centers represents a masterpiece of engineering efficiency and environmental design. These facilities house hundreds of thousands of servers in buildings specifically designed for optimal computing performance and energy efficiency. These facilities are marvels of modern industrial architecture, with sophisticated cooling systems that maintain perfect operating temperatures. They have power distribution networks that provide clean, reliable electricity, and security systems that rival those of the most sensitive government installations. The servers themselves are custom designed and manufactured specifically for Google's needs, optimized for the specific computational requirements of search processing. Every aspect of these data centers, from the server rack layouts to the network cable routing, has been engineered to minimize latency and maximize reliability. They reduce energy consumption while maintaining the computational power necessary to serve billions of searches daily. The scale of these operations challenges comprehension, with individual data centers containing more computing power than entire countries possessed just decades ago. The electricity consumption alone rivals that of medium-sized cities, leading Google to invest heavily in renewable energy sources. These include wind farms, solar installations, and advanced energy storage systems that help power these computational giants with clean energy. The cooling requirements are equally impressive, with sophisticated systems that use everything from traditional air conditioning to advanced liquid cooling. Some systems even use ambient air cooling in climates where outdoor temperatures allow for efficient heat dissipation. These environmental considerations aren't just about corporate responsibility, they're about operational efficiency and long-term sustainability of infrastructure that must operate continuously at massive scale. The networking infrastructure that connects these data centers represents another layer of engineering excellence. It utilizes private fiber optic cables that Google owns and operates independently of traditional internet service providers. These dedicated networks enable direct high-speed communication between data centers, without relying on public internet infrastructure that might introduce delays or reliability issues. The fiber optic cables themselves represent cutting-edge telecommunications technology, carrying vastly more data at higher speeds than traditional internet connections. Some of these cables run under oceans, connecting continents with dedicated high-capacity links that ensure global search operations can share data efficiently. The network architecture includes multiple redundant pathways, so that if one connection fails, traffic automatically reroutes through alternative paths. Users never experience any disruption in search performance. Load balancing across this global infrastructure operates with mathematical precision, automatically distributing computational work across available servers and data centers. This optimizes performance while preventing any single location from becoming overwhelmed. The load balancing systems monitor server performance, network latency, current computational loads, and even predictive models about future traffic patterns. These systems make split-second decisions about where to route each search query for optimal processing. This isn't simple, round-robin distribution, it's sophisticated optimization that considers the specific requirements of each query. It considers the current performance characteristics of different servers and the geographic location of users to ensure optimal response times. The system can automatically shift processing loads between data centers based on time zone patterns. Computational resources follow the sun as peak usage times move across different global regions throughout the day. The software architecture that manages this distributed computing infrastructure represents some of the most advanced distributed systems engineering ever implemented. It coordinates millions of individual computers to function as a unified computational entity. The software systems handle everything from basic resource allocation and task distribution to complex coordination of data replication, backup processes, and system updates. These management systems must ensure that the search index remains synchronized across multiple locations. New content gets distributed efficiently to all data centers, and system updates can be deployed gradually and safely without disrupting ongoing search operations. The complexity of managing this software ecosystem rivals that of managing small cities. Thousands of different applications and services all work together to provide seamless search experiences. Database management across this distributed infrastructure involves storing and synchronizing copies of Google's massive search index across multiple geographic locations. This must maintain data integrity and consistency. The search index, containing information about billions of web pages, must be kept current and synchronized across all data centers. This ensures consistent search results regardless of which servers process your query. This synchronization happens continuously, with new content and updates propagating across the global network as they're processed and verified. The database systems use advanced techniques like distributed consensus protocols and eventual consistency models to maintain data integrity. They allow the system to continue operating even when some servers or network connections experience temporary problems. The database architecture also includes sophisticated backup and recovery systems that protect against data loss. These systems maintain the performance requirements necessary for real-time search operations. Multiple copies of critical data exist across different geographic regions, with automated systems continuously verifying data integrity and replacing corrupted information. The backup systems are designed to handle everything from individual server failures to catastrophic events that might affect entire data centers. This ensures that search services can continue operating and that no information is permanently lost even in worst-case scenarios. Real-time monitoring and automated management systems provide continuous oversight of the entire global infrastructure. They track performance metrics, identify potential problems, and implement corrective actions faster than human operators could respond. These monitoring systems analyze thousands of different performance indicators simultaneously, from server CPU utilization and network latency to user experience metrics and search quality measures. Machine learning algorithms help predict potential problems before they occur, enabling proactive maintenance and resource allocation. This prevents performance degradation before users are affected. The automated management systems can make adjustments to resource allocation, reroute network traffic, and even take servers offline for maintenance automatically. All of this happens while maintaining optimal search performance for users worldwide. The monitoring extends to tracking user experience metrics in real time, measuring search response times, result quality, and user satisfaction. This continuous feedback helps identify when infrastructure changes or optimizations are needed. It provides immediate alerts when performance issues arise that might affect user experience. The systems can correlate infrastructure performance with user satisfaction metrics, helping identify the specific technical factors that most impact search quality and user experience. Security infrastructure protecting this massive computing ecosystem operates at multiple layers. Physical security at data centers includes advanced cybersecurity measures that protect against digital threats and attacks. Physical security includes everything from biometric access controls and surveillance systems to environmental protections that guard against natural disasters and equipment failures. Digital security involves sophisticated intrusion detection systems, encryption of data transmission and storage, and advanced threat analysis. This can identify and respond to potential security breaches before they compromise system integrity or user data. The security systems must protect not just against malicious attacks, but also against accidental damage, human error, and system failures. The security architecture also includes privacy protection measures that safeguard user data while enabling the personalization and optimization that makes search effective. Advanced techniques like differential privacy and data anonymization allow the system to learn from user behavior patterns. This happens without compromising individual privacy or creating detailed personal profiles that could be misused. These privacy-preserving technologies enable Google to provide personalized search experiences while maintaining user trust and complying with privacy regulations worldwide. Disaster recovery and business continuity planning ensure that search services can continue operating even during major disruptions, natural disasters, or large-scale technical failures. The disaster recovery systems include multiple levels of redundancy, from backup power systems and alternative network connections at individual data centers. They include complete failover capabilities that can redirect all traffic from affected regions to operational facilities. The business continuity plans are regularly tested through simulations and exercises that verify the system's ability to maintain search services under various failure scenarios. These preparations help ensure that search remains available and reliable, even during major global events or catastrophic infrastructure failures. The disaster recovery systems also include rapid response capabilities for addressing newly discovered security vulnerabilities, system bugs, or other issues. Dedicated teams of engineers maintain round-the-clock readiness to implement emergency fixes and updates that can be deployed globally within hours. This rapid response capability helps maintain the security and reliability of search services in an environment where new threats and challenges emerge constantly. Environmental sustainability initiatives represent a major focus of Google's infrastructure development. There are extensive efforts to minimize the environmental impact of operating massive computing facilities while maintaining the performance requirements necessary for global search operations. These sustainability efforts include investments in renewable energy sources, advanced cooling technologies that reduce energy consumption. They include server designs that maximize computational efficiency and carbon offset programs that address the environmental impact of global operations. The sustainability initiatives also include research into next-generation computing technologies that could provide even better performance while consuming less energy. The sustainability efforts extend to responsible disposal and recycling of older equipment, with programs that ensure electronic waste is handled appropriately. Google's approach to environmental responsibility includes transparency about environmental impacts, regular reporting on sustainability progress, and collaboration with other technology companies. Research and development efforts continuously work on next-generation infrastructure technologies that will enable even better search performance, lower environmental impact, and new capabilities. These research efforts include everything from advanced processor designs and quantum computing research to new network technologies and artificial intelligence systems. The R&D investments help ensure that Google's search infrastructure continues to improve and evolve, maintaining technological leadership while preparing for future challenges. The research efforts also include exploration of entirely new paradigms for distributed computing and information processing that might revolutionize how search systems operate. These forward-looking research projects help identify promising technologies and approaches that could provide breakthrough improvements in search capability, efficiency, or accessibility. The human expertise required to design, build, and operate this infrastructure represents one of the largest concentrations of technical talent in the world. Thousands of engineers, systems administrators, network specialists, and other technical professionals work continuously to maintain and improve the systems that power global search. These teams include specialists in every aspect of large-scale computing, from hardware design and network engineering to software architecture and security. The collaborative nature of this technical work requires coordination across multiple time zones, cultures, and technical disciplines. This creates one of the most complex and sophisticated engineering organizations ever assembled. Finally, the invisible infrastructure that powers Google Search represents more than just technological achievement. It represents a commitment to democratizing access to information on a global scale. Every engineering decision, every infrastructure investment, and every technical optimization serves the ultimate goal of making human knowledge instantly accessible. This infrastructure makes possible the transformation of a simple typed question into access to the accumulated wisdom of our species. It turns technological complexity into human utility and makes the impossible dream of universal information access into everyday reality. The invisible foundation of search represents one of humanity's greatest collaborative achievements. It's a technological system that serves billions of people daily while continuously evolving and improving to meet the growing demands of global information access. Chapter 10: The Future Frontier. Tomorrow's Search Today. The story of search is far from over. In fact, we're standing at the threshold of the most exciting chapter yet to be written. The boundaries between human curiosity and artificial intelligence blur into something entirely new and extraordinary. What you've learned about today's search technology, impressive as it may be, represents just the opening act in a technological revolution. This revolution will fundamentally transform how humans interact with information, knowledge, and the accumulated wisdom of our species. The future of search promises experiences so intuitive, so seamlessly integrated into daily life, and so remarkably helpful that they will make today's most advanced capabilities seem primitive. We're approaching an era where search won't just answer your questions, it will anticipate your needs, understand your goals, and actively assist in achieving them. This happens through forms of artificial intelligence that approach and may eventually exceed human cognitive capabilities in specific domains. This future isn't decades away, it's emerging today in research laboratories, technology companies, and innovative startups around the world. Brilliant minds are reimagining what becomes possible when human curiosity meets artificial intelligence capable of understanding, reasoning, creating, and collaborating. The integration of generative artificial intelligence into search represents the most significant transformation since the invention of the web itself. These systems create content that don't just find existing information, but can synthesize entirely new content tailored specifically to your needs and circumstances. Future AI search systems will be capable of creating comprehensive research reports on topics that have never been researched before. They will generate personalized learning materials that adapt to your knowledge level and learning style, and produce creative content that combines ideas from multiple sources. Imagine asking, "Create a business plan for sustainable urban farming in my city," and receiving a completely customized analysis. This analysis considers your local climate, regulations, market conditions, available resources, and personal skills. It draws from thousands of sources to create something entirely new and specifically relevant to your situation. This generative capability transforms search from a discovery tool into a creative partner that can help you explore possibilities, develop ideas, and create solutions. The generative AI evolution extends beyond text to include multimodal content creation that combines images, videos, audio, and interactive elements into rich, customized information experiences. Future search could generate personalized video tutorials that demonstrate exactly how to solve your specific problem. It could create custom diagrams and visualizations that explain complex concepts in ways perfectly suited to your learning preferences. It could produce interactive simulations that let you explore different scenarios and outcomes. This capability represents a fundamental shift from consuming existing content to collaborating with AI systems to create new knowledge and understanding. Predictive and ambient search capabilities will revolutionize how we interact with information by anticipating our needs and providing relevant insights before we even realize we need them. These systems will understand your daily routines, upcoming commitments, seasonal patterns, and long-term goals well enough to proactively surface information. Your search assistant might remind you about optimal travel routes before you leave for an important meeting. It might suggest relevant research papers when you're working on a project, or provide weather-appropriate activity recommendations for your weekend plans. This predictive capability transforms search from a reactive tool that responds to queries into a proactive partner. It helps optimize your decisions, activities, and overall life experience through intelligent information delivery. The ambient integration will become so seamless that search capabilities will be woven invisibly into every aspect of your digital environment. Smart home systems will answer questions about your energy usage. Vehicle interfaces will provide real-time information about destinations, traffic, and points of interest. This ambient intelligence will understand context so well that it can provide relevant information without explicit requests. It creates an information-rich environment that enhances daily life without requiring conscious interaction with search interfaces. Conversational AI evolution will transform search interactions from query response exchanges into ongoing collaborative relationships with AI systems. These systems understand your goals, preferences, and working style well enough to serve as genuine research and creative partners. These conversational systems will maintain memory across extended time periods, understand complex project requirements, and provide increasingly sophisticated assistance. You'll be able to engage in month-long research collaborations where the AI helps gather information, suggests new directions for exploration, and identifies patterns across different sources. The conversational sophistication will extend to understanding emotional context and providing appropriate support for different types of information needs. Whether you're dealing with stressful situations that require immediate practical help, exploring creative projects that benefit from inspirational suggestions, or conducting serious research that demands rigorous accuracy. These AI partners will adapt their communication style, information depth, and recommendation approaches based on your current emotional state and immediate needs. Multimodal interface evolution will create search experiences that feel more like natural human communication. These combine voice, gesture, facial expressions, and environmental context to understand what you need and how best to provide it. You'll be able to point at objects while asking questions, use facial expressions to indicate satisfaction or confusion with AI responses. You'll communicate through natural combinations of speech, gesture, and visual cues that mirror how humans naturally interact with each other. These interfaces will understand not just what you're saying, but how you're saying it, what you're doing while you're saying it. They'll understand what environmental factors might influence your information needs. The multimodal capabilities will extend to understanding and generating content across all human communication channels. These create AI systems that can engage through whatever combination of text, voice, images, video, and interactive elements best serves your specific situation. Whether you're a visual learner who benefits from diagrams and demonstrations, an auditory learner who prefers spoken explanations, or a kinesthetic learner who needs hands-on interaction, future search systems will adapt their communication approach to match your optimal learning and information processing style. Augmented reality integration will overlay digital information seamlessly onto the physical world, creating search experiences where information appears exactly where and when you need it. You'll be able to look at any object, location, or situation and instantly access relevant information, historical context, usage instructions, or creative possibilities. You won't need to shift your attention to separate devices or interfaces. Museum visits will become interactive learning experiences with detailed information about exhibits appearing as you look at them. Cooking will become guided experiences with recipe instructions and technique demonstrations overlaid directly onto your kitchen workspace. Travel will become enriched with historical, cultural, and practical information about every location you visit. The AR integration will create persistent information layers that remember your interests and provide ongoing value as you move through different environments. This turns the entire physical world into an information-rich landscape, where knowledge and context are always immediately accessible. This capability represents a fundamental shift from accessing information through separate digital devices to having information integrated seamlessly into direct perception and interaction. Brain-computer interface development represents the ultimate frontier in search evolution, where thought-based queries could eventually eliminate the need for typing, speaking, or even conscious formulation. Early brain-computer interfaces are already demonstrating the ability to detect and interpret basic intentions and commands. Future development could enable direct neural communication with AI systems that understand your information needs at the level of thought and intention. This technology could eventually allow instantaneous access to any information, with AI systems responding to neural patterns that indicate curiosity, confusion, or interest. This happens before you've consciously formulated specific questions. While brain-computer interfaces remain largely experimental and face significant technical and ethical challenges, the potential for direct neural communication with AI systems could revolutionize information access. This represents not just an evolution in search technology, but a potential transformation in human cognitive capability itself. Quantum computing integration could enable search capabilities that process vastly more information simultaneously, explore multiple solution pathways in parallel, and identify patterns impossible to detect. Quantum-enhanced search systems could analyze all possible relationships between different pieces of information simultaneously, providing insights and connections that reveal new understanding. This capability could enable breakthrough discoveries in fields ranging from medical research and climate science to artistic expression and philosophical inquiry. The quantum advantage in search could also enable privacy-preserving computation that allows AI systems to process sensitive information and provide personalized assistance without compromising privacy. Quantum encryption and secure multi-party computation could create search experiences that are both incredibly personalized and completely private. Semantic web evolution will create increasingly structured and meaningful connections between different pieces of information. AI systems will understand not just individual facts, but the complex relationships, implications, and contexts that give information its true meaning and value. The semantic web will evolve into a global knowledge graph, where every piece of information is connected to related concepts. This enables search systems to provide comprehensive understanding rather than just fact retrieval. This evolution will enable AI systems to reason about complex topics, identify logical relationships and contradictions, and provide insights that require genuine understanding. The semantic advancement will also enable more sophisticated fact-checking, source verification, and information quality assessment. AI systems will become capable of evaluating the logical consistency, empirical support, and credibility of different claims and sources. This capability will be crucial for navigating increasingly complex information landscapes and maintaining trust in digital information systems. Personalized AI assistant evolution will create search systems that function as comprehensive life partners. These systems understand your goals, values, preferences, and circumstances well enough to provide guidance and support across all aspects of personal and professional development. These AI assistants will help with everything from career planning and skill development to health optimization and relationship management. They serve as knowledgeable advisors who have access to all relevant information and can provide personalized recommendations based on your unique situation. The assistant evolution will create AI systems that grow and develop alongside you, learning from your experiences, adapting to changing circumstances. These systems will understand not just your immediate questions, but your long-term aspirations, helping you make decisions and take actions that align with your values. Educational transformation through advanced search will create personalized learning experiences that adapt to individual learning styles, paces, and interests. Students will be able to engage with AI tutors that understand their specific learning needs, provide customized explanations and examples, and offer practice problems. These educational AI systems will make high-quality personalized education accessible to anyone, anywhere, regardless of geographic location or economic circumstances. The educational revolution will extend to professional development and lifelong learning, where AI systems help individuals acquire new skills and adapt to changing industries. This capability could democratize access to expertise and enable rapid skill development that keeps pace with technological and social changes. Global accessibility improvements will ensure that advanced search capabilities are available to everyone, regardless of language, literacy level, physical abilities, or technological resources. Future search systems will provide multilingual support that goes beyond translation to include cultural context and communication style adaptation. Voice interfaces, gesture recognition, and simplified interaction methods will make search accessible to people with various physical limitations. Offline capabilities and efficient data usage will extend search benefits to regions with limited internet infrastructure. The accessibility focus will also include economic accessibility, with AI systems that can provide valuable assistance and information access through low-cost devices. This democratization ensures that the benefits of advanced search and AI assistance are available to global populations rather than limited to wealthy individuals. Privacy and ethical development will create search systems that provide powerful personalization and assistance while maintaining user control, data protection, and algorithmic transparency. Future systems will use advanced privacy-preserving technologies that enable personalized experiences without creating comprehensive personal profiles or compromising individual privacy. Users will maintain control over their data, AI interactions, and the level of assistance they receive. The ethical development will also address potential biases, manipulation concerns, and societal impacts of advanced AI systems. This ensures that search evolution serves human flourishing and social good rather than creating new forms of inequality, dependency, or harm. Creative collaboration between humans and AI will enable new forms of artistic expression, scientific discovery, and problem solving. Artists will collaborate with AI systems to explore new creative possibilities. Scientists will work with AI to identify promising research directions. Innovators will partner with AI to develop solutions to challenging social and environmental problems. This collaboration will enhance rather than replace human creativity, providing tools and capabilities that amplify human potential. The creative partnership will evolve into new forms of human-AI collaboration, where the boundaries between human and artificial contributions become fluid. This creates hybrid intelligence that achieves results impossible for either humans or AI systems alone. This collaborative approach ensures that advanced AI capabilities serve human goals and values, while enabling achievements that transcend current limitations. Finally, the future of search represents more than technological advancement. It embodies humanity's ongoing quest to understand, learn, and grow through access to knowledge and wisdom. The evolution of search technology reflects our deepest values about learning, discovery, creativity, and human potential. It creates tools that enhance our ability to satisfy curiosity, solve problems, and contribute to the collective advancement of human knowledge and capability. As search systems become more intelligent, more helpful, and more integrated into daily life, they will continue to serve the fundamental human drive. The future frontier of search promises not just better answers to our questions, but better questions, deeper understanding, enhanced creativity, and expanded possibilities. This technological evolution serves the timeless human values of curiosity, learning, and growth, ensuring that as our tools become more sophisticated, they continue to serve fundamental human purposes. The future of search is ultimately the future of human potential itself, limited only by our imagination and our commitment to using these powerful capabilities. We began this journey with a simple question: what really happens when you Google something? Now, having traveled through the intricate technological landscape of crawlers, indexes, algorithms, and data centers, having witnessed the dance of artificial intelligence and human behavior, we arrive at a profound realization. Having glimpsed the future where thought itself might become the interface to all knowledge, we arrive at a profound realization. The story of search isn't really about technology at all. It's about something far more fundamental and beautiful. It's about the irrepressible human drive to understand, to learn, to grow, and to connect with the accumulated wisdom of our species. Every technological marvel we've explored, from the millisecond ranking of billions of web pages to the global infrastructure that spans continents, exists for one simple purpose: to honor and serve human curiosity. The extraordinary complexity we've uncovered represents humanity's commitment to a radical idea that knowledge should be free, accessible, and available to anyone. Your simple search query, typed into that familiar white box, is actually a profound act of participation in the greatest collaborative project in human history. When you press enter, you're not just retrieving information, you're joining a continuous conversation between human curiosity and the accumulated knowledge of our entire species. Every search connects you to the thoughts, discoveries, and insights of millions of people who came before you. This creates a form of temporal collaboration that transcends the boundaries of time, geography, and culture. The recipe you find was perfected by generations of cooks. The scientific explanation draws from centuries of research and discovery. The historical information represents the careful work of scholars who preserved our collective memory. Through search, you become part of an ongoing dialogue between past and present, between question and answer, between individual curiosity and collective wisdom. This isn't just information retrieval, it's participation in the continuing human story of learning and discovery. Perhaps the most remarkable aspect of this technological symphony isn't its complexity, but its fundamental simplicity and accessibility. A child with a smartphone has instant access to more information than the greatest scholars in history could accumulate in entire lifetimes. A curious teenager in a remote village can explore quantum physics, art history, or molecular biology with the same ease as a professor at the world's most prestigious university. This democratization of knowledge represents one of the most significant equalizing forces in human history. It breaks down barriers that have traditionally limited access to information and education. The invisible infrastructure we've explored, the algorithms we've discovered, the artificial intelligence we've encountered, all serve a beautifully simple purpose: ensuring that human curiosity is never thwarted by lack of access to knowledge. In a world where information was once hoarded by institutions, search technology has created a reality where asking a question is the only barrier to finding an answer. As we conclude this exploration, we're left with a sense of wonder, not just at the technological achievement, but at what it reveals about human nature itself. The fact that we've built these incredible systems, that we've invested so much creativity into making knowledge accessible, says something beautiful about who we are. We are the creatures who cannot resist asking why and how, who build magnificent systems to serve curiosity. We dream of futures where understanding is unlimited. Search technology is ultimately a mirror reflecting our deepest values, our belief that questions matter, that understanding is valuable, that knowledge should be shared. Human potential is limitless when freed from artificial constraints. Every time you search, you're participating in humanity's grandest experiment in collective intelligence. The story of search is still being written, with each query adding a new sentence, each innovation opening new chapters. Your curiosity is both the beginning and the destination of this remarkable journey.